Right now, as you sit still, the Earth beneath you is spinning at more than 600 kilometers per hour. At the very same moment, it's hurtling around the Sun at 30 kilometers per second. But the Sun isn't still either. It races through the Milky Way at 230 kilometers per second. And the Milky Way itself drifts through space, drawn toward a massive cluster of galaxies, each one spinning, orbiting, and twisting like cogs in a cosmic machine. From the smallest atom to the largest supercluster, everything turns. Planets spin, stars rotate, galaxies spiral. Even the tiniest particles, electrons, protons, quarks, carry their own subtle spin. Rotation is not a rarity, it's the rhythm of existence itself. But why? Why does everything, from drifting dust to vast galaxies, spin at all? What first set this motion in play? Was it born in the first moments of the universe? Woven into space and time at the instant of the Big Bang? If we could rewind the universe to that first flash of creation, would we see a spark of rotation already turning, a twist written into the foundation of everything that would ever exist? Tonight, we'll explore how this invisible force, rotation, shaped the universe as we know it, how it built planets, birthed stars, held galaxies together, and forged the magnetic shields that make life possible on Earth. Because the universe doesn't drift quietly through the dark, it spins. Even now, you are in motion. The room feels still, the air calm, but beneath you, the Earth turns once every 24 hours, spinning eastward at nearly 674 kilometers per hour at the equator. In the time it takes you to breathe, you've already traveled nearly half a kilometer through space without ever realizing it. The Moon, too, is moving, orbiting Earth every 27 days at more than 3,600 kilometers per hour, locked in a gravitational dance billions of years old. Together, Earth and Moon race around the Sun at nearly 30 kilometers per second, fast enough to cross the entire width of our planet in under 7 minutes. And our Sun, it's not resting in the sky. It's one of hundreds of billions of stars orbiting the center of the Milky Way, completing a single galactic revolution every 230 million years, traveling at nearly 828,000 kilometers per hour. Yet even the Milky Way is not fixed. It's being pulled toward a mysterious region known as the Great Attractor, a gravitational heart surrounded by thousands of other galaxies, all drifting together in a silent current of cosmic gravity. Look up at the night sky. The stars may seem still, but none of them truly are. Each is moving, some faster than bullets, others slower than drifting ice, their paths weaving through time, reshaping the constellations. The Orion you know today will fade and distort, its stars scattered by the galaxy's eternal spin. Beyond our galaxy, the pattern continues. The local group, more than 50 galaxies bound together, rotates and drifts toward the Virgo supercluster, a titanic web of matter stretching over 100 million light-years. And even that is only one thread in a greater tapestry of motion. A cosmic web still expanding, still turning, ever since the first breath of the Big Bang. So when we say the Earth spins, we're not exaggerating. We are passengers on a spinning planet, orbiting a moving star inside a rotating galaxy, flowing through an ever-turning universe. Even when we stand still, we are traveling faster than we can comprehend. Motion isn't the exception. It's the foundation of everything that exists. But this raises a deeper question. Why does anything spin at all? Why can't a planet form perfectly still? Why does every star and world begin with a turn? The answer is simple yet profound. Motion never disappears. It only changes form. When a vast cloud of gas and dust begins to collapse under gravity, it's never perfectly balanced. There are always slight unevennesses. One region a little denser, another moving a bit quicker. Those tiny differences give birth to a faint twist, and as the cloud shrinks, that gentle spin strengthens, tightening like a dancer pulling in her arms. From that single imperfection, a world begins to turn. Just like a skater spinning faster as she pulls her arms inward, a collapsing cloud of gas speeds up as it shrinks. That's how stars and planets are born, not in stillness, but in motion. This is the power of angular momentum, the cosmic law that keeps rotation alive. It isn't something added after the fact. It's inherited, a memory from the first moment matter began to move. Once rotation begins, it resists change. In the vacuum of space, there's no air to slow it, no friction to stop it. The motion endures, preserved for billions of years. Even our solar system is a fossilized remnant of that ancient spin. 4.5 billion years ago, everything here, the sun, the planets, the moons, was nothing more than a swirling cloud of gas and dust. At the center, gravity drew the densest region inward to ignite the sun. The leftover material flattened into a rotating disk, and from that disk, the planets emerged. Each kept a share of the original spin. That's why most planets orbit in the same direction, aligned in nearly the same plane. Our solar system, in every rotation and orbit, is the echo of a cosmic whirl that began long before Earth existed. But not everything spins the same way. Some worlds are tilted, others overturned. Uranus, for instance, rolls almost on its side, likely toppled long ago by a colossal collision. Venus spins backward, its slow retrograde rotation a relic of violent impacts or tidal forces that once rewrote its motion. Yet even these chaotic moments never erased angular momentum. They merely redirected it. Rotation is not an accident of the universe. It's its nature. Whenever gravity gathers matter, rotation emerges. The only way to stop it would be to balance every motion in every direction perfectly, something nature has never achieved. From the smallest dust grain to the grandest galaxy, spin is inevitable. It's not a byproduct of creation, it's the method of creation itself. The cosmos doesn't need a reason to spin. Spinning is the reason the cosmos exists the way it does. Once something begins to turn, it transforms everything. Rotation isn't background noise. It decides how things form, behave, and endure. Spin is one of nature's most creative forces. Consider a young star. As it forms, its rotation keeps gravity from crushing it completely. Without that spin, the star would collapse into a single point. But rotation creates balance, a quiet tension between falling inward and pushing outward. It flattens the surrounding gas into a thin, glowing disk, and from that disk, planets, moons, and asteroids are born. Spin doesn't just stabilize stars. It builds entire solar systems. It shapes planets too. Earth, for example, bulges at the equator, about 43 kilometers wider than from pole to pole. That's the result of spinning at more than 1,600 kilometers per hour. Centrifugal force pushes outward, balancing gravity's pull inward. Without this subtle balance, our world's surface, its oceans, and even its climate might have been profoundly different. Spin also determines how planets live and die. Fast-spinning worlds generate powerful magnetic fields, born from the motion of molten metal deep within their cores. Those fields act as shields, deflecting deadly solar radiation and preserving atmospheres, a crucial defense for life itself. Earth's steady spin gives us such protection. Mars, on the other hand, spins more slowly. It lost much of its internal heat early on. Its magnetic field faded, and the solar wind stripped away its air. Two planets, one star, but their fates written differently because of rotation. Now scale this to the stars. A slowly spinning star burns calmly for billions of years, while a fast-spinning one lives violently. Its energy turbulent and unstable. When it exhausts its fuel, that furious spin can rip it apart, collapsing it into a neutron star, a stellar corpse no larger than a city, yet spinning hundreds of times per second. These neutron stars fire jets of radiation across space, their pulses so precise that scientists use them as cosmic clocks, the universe's most reliable heartbeat. But when gravity pushes rotation to its limit, beyond even the strength of matter itself, it gives birth to something stranger, a black hole. A black hole doesn't just pull, it twists. Its spin warps the fabric of space-time, dragging everything nearby into a spiral of no return, a phenomenon known as frame dragging. Here, even light itself cannot escape. This is motion at its most extreme, the ultimate proof that rotation shapes reality. Spin builds stars. It shields planets. It carves galaxies and bends space-time. Every structure in the cosmos, every shimmering ring, every elegant spiral arm, every stable orbit is the result of matter finding balance in motion. When we speak of the beauty of the universe, what we're really speaking of is the art of rotation, the quiet, eternal spin that has kept creation turning since time began. The cosmos is never still, because stillness would mean collapse. Instead, it moves in endless rhythm, every atom, every planet, every star locked together in a vast and silent dance of motion. And we are part of that dance, riding on a spinning world orbiting a spinning star within a spinning galaxy, inside a universe that may itself be turning. Everything that spins, spins for a reason. The universe doesn't waste motion, it follows rules, invisible, unbreakable, profoundly simple laws. The first is inertia, the tendency of anything to keep doing what it's doing. If it's still, it remains still. If it's moving, it keeps moving, unless something stops it. That's why a spacecraft can circle Earth for decades, gliding through space without engines, without fuel, without resistance. In the emptiness of the cosmos, there's nothing to slow it down. Once motion begins, it simply continues. Then there's gravity, the quiet architect of everything that turns. Gravity doesn't just pull straight inward, it curves motion into loops. When a planet falls toward a star, it doesn't crash head-on. Its sideways speed bends that fall into a smooth orbit, a delicate balance between falling and flying away. That eternal tug-of-war creates the elegant harmony we call an orbit. But the rule that keeps the universe in rhythm is the conservation of angular momentum. The idea that spin can never be created or destroyed, only passed along, reshaped, shared. A figure skater, a collapsing star, a swirling galaxy, all obey the same law. Shrink and you spin faster, expand and you slow down. The balance never breaks. This single principle connects everything, from the spin of an electron, to the turning of planets, to the majestic spiral of galaxies. It's one universal language, the mathematics of motion itself. Even collisions can't break it. When galaxies crash together, their stars rarely collide, but their spins combine. Their angular momenta blending like colors on a cosmic palette. The result? Vast elliptical galaxies, each still spinning, still preserving that ancient motion. Every rotation in the universe is an inheritance, a gift passed down from one era of matter to the next. From the first atomic particles to the galaxies that burn across the night sky, nothing is lost, nothing wasted. Momentum changes form, but it never ends. From the swirl of a collapsing cloud to the spin of a planet, from the turn of a planet to the orbit of a star, from the spin of a star to the spiral arms of a galaxy, the same motion has flowed through it all. After 13.8 billion years, the universe is still turning with the same pulse it began with. The faint imbalance that started everything still echoes now. Every planet's day, every galaxy's rotation is a trace of that first movement. We live in a cosmos that remembers. It never forgets motion. It preserves it, transforms it, recycles it. A cosmic engine that never switches off. It turns endlessly, powered not by mystery, but by the quiet perfection of physics. Spin brings order to the universe, but it also brings chaos. The same forces that shape stars and planets can just as easily tear them apart, because in space, nothing is perfectly balanced. Every collision, every uneven pull of gravity creates tiny imperfections. And over billions of years, those imperfections grow into grand celestial drama. Look at Saturn's rings, peaceful from afar, thin silver bands of ice and dust gliding in harmony. But look closer, and chaos rules. Each fragment follows its own path, nudged by the gravity of Saturn's many moons. Some pieces are drawn together, others flung apart. What you see is balance born from disorder, a frozen storm of billions of shards, all held together by rotation. And the same principle governs far more violent systems. When two stars orbit too closely, their spins begin to twist together. Gas streams from one to the other, forming a glowing ring of fire. An accretion disk, a whirlpool of matter spiraling toward destruction. Rotation builds the calm and the catastrophic alike. The grace of Saturn's rings and the fury of merging stars. Everywhere, in every scale, the cosmos dances on the same rhythm, the eternal turning of motion that never dies. A whirlpool of matter spins at unimaginable speed. Friction within its glowing disk heats it until it blazes with X-rays, an inferno born from collapse. Around a black hole, rotation becomes something more than motion. It becomes distortion. A spinning black hole does not merely pull matter inward. It twists the very fabric of space-time. This phenomenon, known as frame dragging, means that near such a monster, space itself is being dragged around like a cloak in a storm. Nothing can remain still, not even light. Photons are forced into a spiraling dance, bent around an unseen axis of infinite gravity. It is motion devouring motion, chaos woven into the structure of reality. Even galaxies are not spared this cosmic choreography. From afar, their spiral arms appear serene, like celestial pinwheels frozen in time. But inside lies tension and turmoil, waves of gravity, colliding gas clouds, and the birth and death of stars. Some galaxies spin so furiously that their outer stars should be flung into the void. Yet they hold together, bound by an invisible force. That mystery gave rise to the idea of dark matter, an unseen mass providing the gravity needed to keep the universe from tearing itself apart. Spin is creation and destruction entwined. Too little rotation and gravity consumes everything, crushing it into stillness. Too much, and structure collapses. Systems fly apart, scattering their essence into the abyss. The universe, somehow, walks that knife edge between collapse and explosion. Even our solar system carries the scars of imbalance. The pockmarked faces of the Moon and Mars are relics from an age when orbits wobbled and worlds collided. Yet from that chaos, order slowly emerged. The clockwork harmony of today's heavens is born from ancient turbulence, a reminder that stability is not the absence of chaos, but its transformation. Spin is not a symbol of peace. It is a test. Every rotating world, every orbiting star exists in delicate balance, always one breath away from ruin. That tension between motion and collapse is what makes the cosmos so vividly alive. But when rotation is pushed beyond the realm of the familiar, it becomes something alien. Take a neutron star, the corpse of a massive sun crushed into a sphere barely 20 kilometers wide, yet heavier than our own star. As it collapses, its spin tightens faster and faster until it turns hundreds of times each second. Its magnetic field becomes so intense it fires beams of radiation from its poles. Each flash we detect marks a single turn, a lighthouse of the dead. These are pulsars, and they are the most precise natural clocks in the universe, drifting less than even our best atomic clocks on Earth. But even they are not the end of the story. Spin a neutron star fast enough, and gravity wins one last time. The star collapses again into a black hole. Here, rotation reaches its ultimate form. A black hole can spin at nearly the speed of light. At that velocity, the laws of physics themselves warp. Space-time twists, dragged by the black hole's rotation in an effect so real, it could carry you along even if you tried to resist. Within this strange region, the ergosphere, motion is no longer a choice. Everything must rotate, even light itself. These are called Kerr black holes, objects so extreme that their spin defines their very being. If they ever stopped rotating, the ergosphere would vanish, and their structure would change entirely. But none of the black holes we've found show signs of rest. Every one of them spins, some completing a full rotation in less than a millisecond. At those speeds, the energy bound in their rotation could rival the output of entire galaxies. In the end, spin is not just motion, it is the heartbeat of the cosmos. From the smallest atom to the greatest black hole, everything that exists dances to that rhythm. Some astrophysicists believe that the vast jets of plasma erupting from black holes, streams stretching thousands of light years, are not powered by falling matter, but by the black hole's own spin. Through a process known as the Blandford-Znajek mechanism, rotation itself is transformed into pure energy. Motion becomes power, gravity becomes fire. But spin does not belong only to the colossal. It exists in the smallest places too, woven into the foundation of reality. At the quantum scale, particles like electrons, protons, and neutrons all possess spin. Yet, it is not rotation in any familiar sense, not something that can be pictured as a sphere turning. Quantum spin is intrinsic, a property built into the very identity of matter. It gives rise to magnetism, chemistry, and the architecture of the atom. Without it, atoms would not form. The world would dissolve into a shapeless blur of particles. Spin, even at its tiniest, is what makes matter solid, what allows existence to take form. From the smallest particle to the mightiest black hole, spin defines everything. It shapes the visible and the invisible, the tangible and the abstract. It binds the universe together, yet at its extremes, it reveals the limits of our understanding. Because when motion nears the speed of light, and spin begins to drag time itself, we glimpse something humbling. The universe does not simply spin within space-time. It spins space-time itself. But how do we know this? How can we be sure that planets turn, that stars rotate, that galaxies swirl through the void, when we cannot touch or see most of them up close? The truth is, We've been watching motion reveal itself for centuries, and the universe has been leaving clues all along. The first proof came not from the stars, but from right here on Earth. In 1851, a French physicist named Léon Foucault suspended a great pendulum from the dome of the Pantheon in Paris. He set it swinging and left it. Slowly, its direction began to shift, not because the pendulum changed, but because the Earth rotated beneath it. The swing twisted through a full circle every 24 hours, a quiet, elegant revelation. For the first time, humanity saw its world spin, not as theory, but as motion. A few decades later, telescopes extended that insight beyond our world. Astronomers tracked the shadows of Jupiter's moons and saw the gas giant turn. They watched dark sunspots drift across the face of the sun. They measured the subtle Doppler shift of starlight, the telltale change in color as one side of a star moves toward us and the other moves away. From that faint difference in hue, they could calculate the exact speed of a star's rotation, even from billions of kilometers away. In the 20th century, our instruments grew sharper still. Radio telescopes began to detect the rhythmic pulses of neutron stars, perfectly timed beacons of spin. Each pulse that reached Earth was a rotation, a heartbeat of cosmic precision. Their consistency was so absolute that even the slightest irregularity revealed when a star had shifted, collided, or slowed, a whisper of mechanical rhythm echoing through the dark. Then came the space telescopes, Hubble, Chandra, Gaia, and now the James Webb. These machines do more than take pictures. They measure motion. Gaia, for example, tracks over 1 billion stars, recording their drift across the Milky Way with such precision that it can detect the subtle wobble of our own sun as its planets tug on it in orbit. From those delicate wobbles, we've discovered thousands of new worlds, each one spinning, dancing, balancing its own cosmic rhythm. Even the rotation of black holes, once a pure abstraction, can now be measured. By studying the X-rays emitted from the superheated disks of gas swirling around them, scientists can calculate how fast those black holes must spin. Some rotate so furiously that the very edge of space is dragged around at nearly the speed of light. The Event Horizon Telescope, which captured the first image of a black hole's shadow, showed something astonishing, the ring of light glowing brighter on one side. Not an illusion, not an artist's vision, but rotation itself bending light, warping time, sculpting reality. And the evidence doesn't end there. Instruments like LIGO and Virgo, sensitive enough to feel distortions in space-time, can now hear the spin of black holes and neutron stars as they merge. Each faint chirp in the data carries their rotational fingerprint, the record of how they turned before they collided and vanished into one. We are no longer just seeing light from motion. We are listening to space-time vibrate with it. From the swinging pendulum of a cathedral to the ripples of merging stars, we have traced a single truth. Everything that exists, from atoms to galaxies, moves in circles. Spin is not a property of the universe. It is the universe. From a swinging pendulum to signals that cross billions of light years, the universe has been repeating one message since the beginning. Nothing is still. Everywhere we look, in every wavelength we capture, through every instrument we build, motion never ceases. The cosmos turns, hums, and breathes. And through its endless movement, we've learned not just where we are, but that we are part of something alive, a universe that never sleeps. When we speak of spin, we imagine rotation, planets turning, stars revolving, galaxies swirling through the dark. But spin is deeper than that. It is the hidden thread stitching the universe together. It links gravity with magnetism, light with time, matter with meaning. Begin at the smallest scale. The electrons inside every atom of your body. Each carries both charge and spin, and that combination gives rise to magnetism. Every magnet that clings to your refrigerator, every compass that points north, even Earth's vast magnetic shield, all exist because of the silent alignment of spinning electrons. Without that microscopic dance, magnetism would vanish, your compass would fail, and the solar wind would strip Earth bare. Spin is what stands between life and cosmic radiation. But its role goes beyond protection. Spin organizes everything. The way electrons spin determines how they arrange themselves in atoms, how chemical bonds form, how matter behaves. Change the rules of spin even slightly, and chemistry itself collapses. Stars could not fuse, planets could not hold form, life would lose its structure. Scale upward, and the same principle drives the great machinery of worlds. Deep below Earth's crust, molten iron churns and whirls as the planet spins. That motion creates the geodynamo, a self-sustaining magnetic field that wraps our world in invisible armor. Jupiter's even faster rotation powers a magnetic field so enormous it stretches millions of kilometers into space, trapping radiation and sculpting auroras the size of Earth itself. Spin turns movement into magnetism, and magnetism in turn guides motion. It is a loop with no beginning or end, a cosmic handshake between energy and momentum. Even light, the fastest thing that exists, carries spin. A photon doesn't spin like a ball. It holds intrinsic angular momentum, giving rise to polarization, the orientation of its electric and magnetic waves. Polarized sunglasses block glare because of this property. Astronomers use it to decode the architecture of galaxies, reading polarization patterns in starlight like a signature written by spin itself. Every beam of light crossing the cosmos carries its own faint record of rotation, a fingerprint of motion burned into its structure. Then there is gravity, the quiet architect of motion. Einstein's general relativity tells us that mass curves space-time, but when mass spins, it doesn't just curve, it twists. This effect, called frame dragging, means that rotation can literally pull time along with it. Near a spinning planet or black hole, time itself flows differently. The faster the rotation, the deeper the twist. NASA's Gravity Probe B experiment proved this exquisitely. After years of orbit, its instruments detected how Earth's spin drags space-time by a few thousandths of a degree, a subtle but undeniable confirmation that our planet slightly warps time simply by turning. Even here, even now, the seconds you experience are gently curved by Earth's motion beneath your feet. From electrons to planets, from black holes to the very geometry of space-time, spin is everywhere. It doesn't just cause movement, it defines relationships. It links matter to energy, energy to magnetism, magnetism to time. It is not an isolated property, but a universal language, a choreography of creation. Every rotation, every orbit, every pulse is part of the same grand conversation that binds the cosmos together. Spin isn't just how the universe moves, it's how the universe communicates. Now imagine for a moment a universe without motion. No planets orbiting, no stars rotating, no atoms trembling, only stillness. In that frozen silence, nothing would change. And without change, there would be no time. Because time, at its most fundamental level, isn't something the universe has. It's something the universe does. Time is motion measured, the unfolding of one moment into the next, and spin, more than anything else, keeps that unfolding alive. Every rotation in the cosmos, every turning planet, every flashing pulsar, every spinning electron is a tick in the great cosmic clock. Each revolution, a heartbeat of existence. The faster the spin, the faster the rhythm of time itself. Without those cycles, without that constant, graceful turning, there would be no before, no after. Spin gives time its structure, its pulse, its meaning. And on the human scale, that truth is written into every moment. We count days by the turning of Earth. We count years by our orbit around the sun. Every calendar, every clock, every second of our lives, all are measured by motion. Spin defines not only the universe we see, but the very flow of time that allows us to see it. Even the tiniest motions within atoms, the oscillations, the subtle flips of their internal spins, form the very basis of atomic clocks so precise they lose just a single second in 100 million years. Every measure of time we know is born from motion, from something turning, vibrating, or repeating its rhythm in the dark. But the connection between motion and time runs far deeper than the machinery of clocks or the turning of calendars in physics. Time and energy are bound together, and motion, especially the pure, endless dance of rotation, is one of the most elegant forms of energy the universe allows. When something spins, it holds kinetic energy, a balance between motion and stillness. Yet as it loses that energy through friction, radiation, or collision, it drifts toward equilibrium. That steady slide into disorder, known as entropy, is what gives time its direction. Forward. If every atom, every star, every galaxy were to fall into perfect stillness, entropy would cease, and with it, the flow of time itself. That isn't poetry, it's the quiet truth of thermodynamics. The arrow of time exists because energy always spreads, from order to chaos, from symmetry to decay. Spin is the universe's way of carrying that transition forward. It's how stars share their heat with the void, how galaxies evolve and spiral, how the cosmos avoids collapsing into frozen perfection. And then came Einstein, revealing that time itself is not absolute. The faster something moves, the slower time flows for it, compared to an outside observer. Spin, therefore, doesn't just mark the passage of time, it alters it. A neutron star spinning hundreds of times per second experiences time differently from the emptiness around it. A rotating black hole twists both space and time into a single inseparable whirlpool of existence. In these regions, motion does not merely occur within time, it creates the very conditions for time to exist at all. Every spin in the universe, from the smallest electron to the grandest galaxy, is its own tiny clock, beating in rhythm with the fabric of reality. Together, they compose the great cosmic symphony through which all beings move. So when you gaze up at the stars, you are not just seeing distance, you are witnessing time itself, written in rotation. Every orbit, every flicker of starlight, every cosmic turn is a chapter in time's unfolding story. Without motion, there would be no change. Without change, no time. And without time, the universe would fall into silence. Spin is not merely how matter moves through time, it is how time moves through matter. Every world begins with a turn. Billions of years ago, before Earth ever breathed, our solar system was nothing but a swirling cloud of dust and gas, restless, chaotic, alive with collisions. Yet hidden within that chaos was a pattern, a faint collective spin, and that spin would decide everything. As gravity drew matter inward, the cloud began to flatten, forming a vast rotating disk around the newborn sun. This was not chance, but the law of angular momentum. As something collapses inward, it must spin faster to conserve its motion. That ancient rotation held the collapsing cloud together, preventing it from falling entirely into the sun. It gave the universe time to build. Dust became stone, stone became worlds. Each planet that formed inherited its share of that primeval spin. That is why nearly all planets orbit the sun in the same direction, along a flattened plane, a cosmic memory of their shared birth. Even now, billions of years later, the shape of our solar system is the fossil imprint of that first rotation. Spin did more than sculpt the orbits of planets. It shaped their nature. The turning of a planet on its axis creates day and night, setting the rhythm for wind, weather, and warmth. Without that spin, Earth would be divided forever. One side scorched by unending sunlight, the other locked in eternal ice. But rotation stirs the balance, weaving light into shadow, making our world habitable. Even the tilt of Earth's axis, a gentle 23.5 degrees, brings the slow dance of seasons, the rise and fall of life's rhythms across the centuries. Every turn, from the smallest electron to the grandest planet, is a whisper of time's pulse. To spin is to exist. To move is to remember that the universe is not static, but endlessly breathing, endlessly becoming. If Earth's tilt was smaller, our world would fall into a dull, unchanging calm. The seasons would fade. The climate would stagnate. If that tilt were greater, the pendulum would swing violently from burning heat to frozen silence. The balance we live within, this gentle rhythm of life, light, and growth, exists only because our planet's spin is precisely what it is. And we are not alone in that delicate choreography. Every planet tells its own story through the way it turns. Mercury, the slow wanderer, spins so lazily that one day lasts nearly 2 of our months. Venus, wrapped in its thick, suffocating clouds, spins backward, as if time itself flows in reverse. Mars turns at a familiar pace, but its smaller heart makes its climate fragile and easily lost. Jupiter, the roaring giant, spins so fast that its day ends in just 10 hours, a furious motion that fuels storms larger than entire worlds, including the ancient red eye that has raged for centuries. Even moons bear the mark of motion. Our moon turns exactly once for every orbit around Earth, which is why it forever shows us the same pale face. This perfect equilibrium, a cosmic handshake between gravity and spin, is called tidal locking. Without it, the moon's pull on Earth would constantly shift, tearing the tides apart, breaking the quiet rhythm that cradles life along the shores. Spin doesn't stop at planets or moons. Asteroids tumble without pattern. Comets twirl as sunlight warms their icy scars. Even dust grains adrift between the stars rotate gently as they drink in light. At every scale, spin brings order to chaos. It turns random motion into rhythm, structure, and meaning. Our world was not forged in stillness. It was carved from motion. The slow, patient rotation of stone and dust under gravity's unseen hand gave our home its shape, its weather, its seasons. And in time, its life, every sunrise, every whisper of wind, every ocean tide is part of that ancient motion still unfolding. We live on a spinning world born from a spinning star in a universe that has never stopped turning. Yet if the cosmos seeks order, why doesn't everything spin the same way? At first glance, it almost does. Most planets orbit the sun in the same direction, and most galaxies spiral either clockwise or counterclockwise, depending on how we see them. But look closer and you find small imperfections, cracks in the symmetry, and those tiny cracks may hold the key to how everything began. In our solar system, almost every world follows the same direction of motion, a memory of the original rotating disk that formed them. Yet two planets defy that ancient law. Venus spins backward, and Uranus lies on its side, rolling like a barrel through space with its poles pointing toward the sun. These aren't accidents. They are cosmic scars, the aftermath of ancient collisions that forever altered their spins. The universe doesn't erase its history. It keeps it in motion. But the mystery runs deeper. When astronomers observed thousands of galaxies, they found something strange. A slight excess of galaxies spinning in one direction over the other. The imbalance was tiny, only 1 or 2%, but significant enough to make scientists wonder if the universe itself has a faint global rotation. If that's true, it would mean the cosmos carries a preferred direction, an echo, perhaps, of the conditions imprinted at the moment of the Big Bang. Even in the smallest realms, the pattern continues. In the quantum world, particles and their mirror opposites do not behave identically. This discovery, known as parity violation, shocked physicists in the 1950s. They had believed the universe's laws would look the same in a mirror, but when they observed certain decaying atomic nuclei, they found a preference. Particles favored one direction of spin over the other. The universe, it turned out, had a subtle handedness. That discovery shattered one of physics' most beautiful assumptions: perfect symmetry. And that broken symmetry may be the very reason we exist at all. If matter and antimatter had been born in perfect balance, they would have annihilated one another instantly after the Big Bang, leaving behind nothing but light. But something, perhaps a minute difference in how particles spun or decayed, gave matter the slightest edge. That almost invisible bias was enough to leave behind the atoms that built stars, galaxies, and life itself. Spin, then, may be the fingerprint of that ancient asymmetry, a whisper from the universe's first choice. It is not just motion. It is evidence, a signature written into the laws of nature that tipped the scales toward existence. So when you gaze at the spiral arms of a distant galaxy, remember that graceful swirl may not be random. It could be the cosmos's own autograph, a direction inscribed into its birth certificate. In a universe that prizes balance, it was imbalance, a small, imperfect spin that made everything possible. It's the tiny imperfections, the small fractures in symmetry, that make everything possible. Had the universe been perfect, it might never have existed at all. Perfection means balance, a flawless stillness where every force cancels another, leaving no room for motion, growth, or time. The cosmos needed a flaw, a delicate misstep in its symmetry, to begin. In the first trembling moments after the Big Bang, there was no harmony, no order, only energy, dense, chaotic, alive with potential. Within that storm, some regions held slightly more matter, some carried a touch more spin, some just a little less. These minuscule variations, 1 part in 100,000, shattered the mirror of perfect symmetry. And from that fracture, everything began to unfold. Matter triumphed over antimatter. Gravity gathered the uneven plasma fog into knots of creation. Each knot spun a little differently, some clockwise, others counterclockwise, and those faint twists became the seeds of galaxies. Imperfection, not perfection, sculpted creation. It allowed energy to flow, time to move forward, and space to expand. Had symmetry remained unbroken, the universe would have stayed a silent ocean of radiation. No stars, no worlds, no breath, no story. Stillness would have been eternal death, but imbalance, that single cosmic bias, gave rise to motion. Every atom, every star, every living being is a ripple from that first tiny asymmetry. The universe remembers it still. That perfection does not create, motion does. And motion was born from chaos that dared to be uneven. Perhaps that is the deepest truth written across the stars. Beauty is not symmetry, but the dance between opposites. Every spiral, every orbit, every turning world is an echo of that original imperfection that gave the universe permission to move. The cosmos did not begin in peace, it began in imbalance. And within that imbalance, it discovered direction. Now imagine rewinding the clock beyond galaxies, beyond atoms, beyond even light, to the instant when the universe was smaller than a grain of sand, denser than the heart of a star, filled with impossible energy. In that moment, there was only pure potential. Quantum fields trembled. Space itself quivered with fluctuations, tiny wrinkles in reality, each a surge of energy, a microscopic whirlpool of motion. These were not random tremors. They carried spin, the universe's first fingerprints of rotation, the birthmark of movement itself. Then came inflation. In less than the blink of an eye, the universe expanded faster than light, stretching those subatomic ripples into cosmic spirals. The smallest quantum eddies became vast vortices of matter and energy, their shapes etched permanently into the structure of the cosmos. Billions of years later, galaxies would trace those ancient swirls, following invisible rivers of spin born in the first fraction of a second. That was the first motion. The moment when rotation became destiny. It wasn't just something turning in space. It was space itself that turned. The laws of physics, gravity, electromagnetism, quantum mechanics were still crystallizing from the heat of creation. But one truth was already written. Motion cannot vanish, only change form. As the cosmos cooled, quarks spun together into protons and neutrons. Those joined to form atoms, their electrons orbiting in restless clouds, faint echoes of that first universal spin. Every atom in your body carries that memory, that ancient movement. You are made of motion, shaped by the first rotation that ever was. If you could have stood there in that impossible instant when time itself began to tick, you would not have seen light or heard sound. You would have felt motion, the universe twisting itself into being. From that first turn came all the rest. The swirling of galaxies, the orbits of planets, the pulse of blood, the rhythm of thought. The first spin was when chaos learned to dance. When the universe took its first step toward awareness, time did not arrive as a straight waiting road. It emerged as a trail carved by motion. In that newborn cosmos, change was the only constant. Fields rippled, particles flickered into being, and space itself stretched. But change needs a measure. It needs something to turn, something to count its passing. And so, from that first spin, time began. It's the tiny flaws that make everything possible, the delicate cracks in symmetry that let existence breathe. If the universe had been perfect, it might never have been born at all. Perfection is stillness, where every force cancels another, where balance is so exact that nothing stirs, nothing changes. In that frozen harmony, no motion could ever spark, no light could ever form. But the cosmos began with a flaw, a tremor in the mirror. In the first instant after the Big Bang, there was no calm, no symmetry, only chaos. Dense, trembling, full of restless potential. Within that chaos, tiny imperfections appeared. One region with a hint more matter, another with a touch more spin, a few with barely less. These differences, smaller than one part in 100,000, were enough to fracture the perfect reflection of the newborn universe. From that fracture, everything unfolded. Matter triumphed over antimatter by the smallest margin. Gravity gathered uneven clouds of plasma into knots, each spinning slightly differently. Some clockwise, others the opposite. Those faint twists became galaxies. So it wasn't perfection that shaped creation. It was imperfection that set it free. Because only imbalance allows energy to flow. Only a tilt in symmetry allows time to move. If perfection had remained, the universe would have been a silent sea of radiation. No stars, no worlds, no breath. But one small bias tilted the scales and motion began. Every atom, every planet, every pulse of life is a ripple from that first broken symmetry. The universe remembering that stillness is sterile and motion is fertile. The cosmos was not born from harmony, but from chaos, daring to be slightly uneven. And perhaps that is the oldest truth hidden in starlight. Beauty is not symmetry, but the dance between opposites. Every orbit, every spiral, every rotation is an echo of that ancient flaw. The first permission the universe gave itself to move. Creation did not begin with peace. It began with imbalance, and in that imbalance, it found direction. Now rewind time, past galaxies, past stars, past atoms. Back to when the universe was smaller than a grain of sand, a trillion times denser than any star's heart. There was no structure, only blinding energy, condensed into pure potential. Quantum fields rippled wildly, birthing wrinkles in space-time. Tiny whirlpools of motion, flashes of energy, the first trembling gestures of form. These fluctuations carried spin, microscopic rotations, the fingerprints of the newborn universe. Then came inflation, a surge faster than light itself. In less than a heartbeat, the universe expanded, stretching those quantum eddies into cosmic swirls. The tiniest twists in energy became vast rotations of matter and gravity, imprinted forever in the geometry of everything. Billions of years later, galaxies would form along those invisible spirals, tracing the original currents of motion. That was the first spin, the moment motion became destiny. Not a rotation within space, but the rotation of space itself. The laws of physics were still being written. Gravity, electromagnetism, quantum rules not yet settled. But one principle had already taken hold. Motion cannot die. It can only transform. As the universe cooled, quarks spun together into protons and neutrons. Those joined into atoms, their electrons spinning in eternal probability clouds, echoes of that first cosmic twist. Every atom in your body still remembers it. Each carries the faint rhythm of the universe's original spin. If you could stand in that first instant when time began, you would not see light or hear sound. You would feel motion itself, twisting reality into existence. From that first turn came everything: the swirl of galaxies, the orbit of planets, the rhythm of living hearts. The first spin was when chaos learned to dance, when motion became meaning. Time was not born ready-made. It emerged as the trail motion carved through chaos. Change became the only law. Fields trembling, particles flickering, space stretching outward. But change needs rhythm, a heartbeat to measure itself against. Spin gave it that rhythm. A single rotation is a promise: begin here, return here. One turn defines a moment. From those first swirling vortices stretched by inflation, motion began to loop, and each loop gave time a foothold. Electrons carried spin, a built-in pulse that has never stopped since. Every moment you live, every breath, every heartbeat, all of it is synchronized with that first cosmic rotation. We are not observers of motion. We are made of it. The universe spins within us, remembering its first imperfection, and the beautiful imbalance that made it all begin. Atomic nuclei began to precess like tiny spinning tops, each turning with a rhythm written in fire. As matter cooled and joined together, these microscopic metronomes multiplied, weaving a lattice of cycles through the growing fabric of reality. Yet time did not move forward simply because the universe began to tick. Direction needed a preference, a choice. The cosmos found that choice through a long chain of quiet asymmetries. As the hot plasma thinned and slipped out of equilibrium, reactions froze in the memory of matter. Charge and parity fell slightly out of balance, a delicate violation, a whisper of bias in how particles decayed. That tiny asymmetry tipped the scale just enough for matter to endure while antimatter vanished into light. Each frozen decision increased entropy, the slow spreading of energy from concentrated to diffuse, and the arrow of time stretched longer. Spin made that expansion graceful instead of chaotic, turning collapse into choreography. Imagine a collapsing cloud of gas. Gravity pulls inward, but rotation resists. The cloud flattens into a disk instead of falling into ruin. Angular momentum cannot die. It redistributes, transforming collapse into order. Across the early universe, the same story played out again and again. Eddies turned into orbits, orbits into rotations, rotations into structure. Motion slowed the rush toward equilibrium, buying the cosmos time to build complexity. Quantum mechanics added its own poetry to the process. In the furnace of the first second, wave functions overlapped and interfered, each possibility a shimmering note in the cosmic chord. But as the universe expanded, interactions with the environment forced choices. Decoherence silenced the other notes, fixing outcomes, and many of those outcomes carried rotational character. Where a field could wind, it wound. Where a phase could twist, it twisted. Spin became the record of decisions made and kept, the handwriting of the early universe etched in motion. Now imagine the first true clocks, the idea of precision itself being born. A pulsar, the remnant of a collapsed star, spins with such perfect rhythm that its pulse defines time. Long before any pulsar existed, the blueprint of that perfection already lived inside the laws of spin and conservation. The universe was still learning to cool, yet it was already designing instruments of order. Time also learned to bend. Rotation did not only mark time, it sculpted it. Wherever mass spun, space-time twisted around it. Even in those first epochs, the equations carried the promise of frame dragging, a guarantee that motion and time would forever intertwine. Later, around fast-spinning black holes, that promise would become a spectacle. Clocks near the whirl would disagree with clocks far away, but the principle was ancient. To rotate is to rewrite the tempo of time. On our own fragile scale, we still borrow that inheritance. We count days by the Earth's spin, seasons by its tilt, years by its orbit. Our most precise instruments measure the flips of atomic spins, the smallest, most perfect cycles. All of our words for before and after rest upon these ancient turns. Every idea of sequence of cause and consequence is written on a circular foundation that began when the universe first dared to turn. If time is the story of change, then spin is the punctuation that makes that story legible. Without rotation, events would blur together, smearing into an unbroken haze, ink without lines. With spin, events recur. Recurrence breeds rhythm. Rhythm invites memory, and memory gives rise to meaning. So when did time begin to turn? Perhaps the truest answer is this. Time began when motion learned to return. From the first closed paths in quantum phases to the vast orbits of galaxies, the universe taught itself to keep time by moving in circles. The arrow of time points forward because entropy demands it. But the ticks, the beats that let us hear that arrow, are born of rotation. Which leads to a deeper question. If time can be heard, what did it sound like when the cosmos first found its rhythm? Before the first stars, before atoms even cooled, the young universe could sing. Not with air, not with strings, but with gravity and light. In the first 380,000 years, the cosmos was a dense, glowing plasma. Photons and baryons locked together in a single fluid. Push that fluid in one place and it rebounded in another. Compression followed rarefaction, back and forth in a steady, perfect rhythm. The first cosmic music, a deep, resonant hum, rippled through space. Before there were galaxies, before there was light, the universe was already keeping time through sound. These were not metaphors. They were real pressure waves, true acoustic oscillations etched into the young expanse of space. Each wave carried a tempo, its beat defined by the speed at which light and matter could speak to one another. Larger regions pulsed with deeper, slower notes, while smaller patches rang with higher tones. And through that cosmic symphony, rotation joined as a subtle harmony. Vorticity, tiny curls of motion that tried to twist the plasma as it sang. Most of those curls faded, erased by the universe's smooth expansion. But not all. Wherever the medium could hold a trace of spin, it did, and that spin added texture to the melody. Inflation, the great cosmic stretcher, had already prepared the score. It amplified the quantum fluctuations and laid down their phases with uncanny coherence. So when the primordial plasma began to sing, distant regions moved in synchrony, as if drummers scattered across an endless desert were hearing the same downbeat through the wind. The universe did not hum at random. It performed a composition with recognizable motifs, a structured rhythm carried on the fabric of reality itself. We can still read its ancient sheet music. When atoms first bound together and the fog of plasma cleared, the last light of that era began its long journey, a 13.8 billion year voyage across the dark. That light is the cosmic microwave background, the faint glow still draped across the sky. Embedded within it are the fingerprints of those first notes. The hot spots and cold spots, the peaks and troughs, the resonant overtones of a cosmic chamber the size of the early universe. But beneath that glow lies a deeper rhythm, gravity's own channel. Even before the plasma decoupled, space itself was shaking. Primordial gravitational waves, ripples in geometry, raced outward at light speed. They carried no charge, left no ion trail, and passed through matter as if through mist. Where they met the photon sea, they left a signature, a faint twist in the polarization of light, a curl-shaped pattern that scientists still search for today across the heavens. If we ever detect those curls clearly, it would be like hearing the opening bars of creation with our own instruments, the first heartbeat of time itself. Spin was not merely a companion to those waves. It powered their structure. A rotating mass radiates gravity just as a struck bell radiates sound. In the early universe, patches of matter that held angular momentum tried to whirl even as the surrounding fluid resisted. That struggle left its trace in the cosmic spectrum. Sidebands, gentle distortions, small harmonics that later shaped the preferred alignments of galaxies and the winding filaments of the cosmic web. Listen closely to what the data reveal. The spacing of the acoustic peaks tells us the tempo of expansion, the rhythm of how fast the universe stretched. Their relative heights whisper the balance between ordinary matter, dark matter, and radiation. The sections of the orchestra. The polarization patterns murmur of twists and rotations, faint echoes of ancient gravitational waves. From a few harmonics, we can reconstruct the entire performance. The size of the hall, the nature of the instruments, the score of the players. If you could stand within that newborn universe, you would not hear it in the way human ears hear. There was no air to carry sound. Yet your instruments, your detectors, your mind, would feel the polyphony of oscillations. Density waves surging and falling, curvature ripples spreading through space, rotational modes trying to take hold. You would witness a chorus where motion itself was both melody and meter, the universe literally singing itself into structure. And the song did not end when the plasma cleared. As gravity claimed its role, the great waves of sound broke into visible form, crests condensed into clusters, troughs stretched into vast voids. The rhythm slowed as cosmic expansion stretched the intervals of the dance. Galaxies found their downbeats at the intersections of filaments, where flows converged with a subtle twist. Disks took shape, and stars ignited, spin turning the score into architecture. There is poetry in this, but also discipline. The universe is not improvisation. It is a theme and variation played with crystalline precision. Conservation laws keep the rhythm steady. Initial conditions set the key and tempo. Non-linear growth writes the solos, the unexpected crescendos and cadences. And through it all, rotation provides the grace notes, the delicate spins and turns that make the music unforgettable. When we build detectors to catch the faint tremors of gravity, we are not merely chasing technological triumph, we are tuning our ears to the first music ever performed. Each chirp from merging black holes is a later movement, an encore echoing through a hall full of ancient reverberations. To reach the overture, we must trace those harmonics backward, through the cosmic microwave background, into that early age when sound and spin spoke the same language. The overture is nearly complete. In the next act, the melody will condense into form. Ripples will become rivers. Rivers will braid into a web. The web will twist itself into spirals. From the sound of creation, we step into its sculpture. And there, at the crossroads of wave and whirlpool, the first galaxies will learn to turn. By the time the universe was a few 100,000 years old, its song had faded into silence. The light that once scattered in every direction now streamed freely. The cosmic microwave background, the final whisper of a once blinding fire. Yet the echoes of those early oscillations never truly vanished. They remained etched into matter itself, faint ripples, tiny overdensities, no more than 1 part in 100,000, that would become the scaffolding of everything to come. Then, gravity took the stage. Wherever density was slightly higher, matter began to fall inward, drawn toward its own invisible weight. But the collapse was not smooth. It carried memory. the faint inheritance of motion. Each knot of gas and dark matter bore a delicate spin, seeded by vorticity from the universe's earliest moments of inflation, amplified later by turbulence as the cosmos cooled. The universe had stopped singing, but it had begun to dance. As regions collapsed, angular momentum governed every movement. The same principle that makes an ice skater spin faster when she pulls in her arms applied now on a cosmic scale. Vast halos of gas, shrinking under gravity's pull, began to rotate more rapidly. The first proto-galaxies emerged, not as still clouds, but as spinning tempests of gas and shadowed dark matter. Modern simulations like Illustris and Eagle recreate this birth in exquisite detail. They show a cosmic web of dark matter filaments stretching across the void, winding and intersecting at glowing nodes where galaxies ignite. Each filament carries angular momentum, channeling spin into newborn galaxies like rivers feeding whirlpools. The pattern is universal and astonishingly consistent. Galaxies are not scattered randomly, but align along these filaments, their spins tracing the silent flow of the unseen dark matter that sculpted them. Even the invisible parts of the universe seem to remember how to turn. The underlying physics is both simple and profound. In an expanding universe, collapsing regions must shed their excess angular momentum to settle into stable forms. They do this through tidal torques. Gravitational tugs exchange between neighboring structures as they grow, twisting one another in a vast cosmic negotiation of spin. One slows while another accelerates, but the total angular momentum of the universe remains conserved. Motion redistributed, never lost. Over billions of years, this interplay of torque and collapse carved the familiar galactic forms we see today. Disks, spirals, bulges, and bars, each a frozen expression of angular momentum striving for equilibrium. The Milky Way itself is one of these survivors. A vast, rotating city of stars orbiting a dark center. Each motion a continuation of that first ripple in the infant plasma. From subatomic spin to galactic swirl, the same truth endures. Motion, once begun, persists. The ripples of creation became rivers of rotation. Those rivers, over cosmic time, chiseled the architecture of the universe. Every galaxy is a record of that motion, a fossil of rotation frozen in light. Grand spirals stretch their arms like whirlpools of starlight, while smoother ellipticals rotate more quietly, their youthful energy long since dispersed through collisions and mergers. The shape of each galaxy is a reflection of its spin. High angular momentum yields graceful flat disks where rotation balances collapse. Low spin allows gravity to dominate, pulling matter inward into rounder spheroidal forms. In this way, spin is not merely a property, it is destiny. And now, with the James Webb Space Telescope, we can glimpse that destiny at its dawn. Galaxies seen only a few 100 million years after the Big Bang already show ordered rotation, some spinning at over 200 kilometers per second, in a universe so young that it has barely turned once. These cosmic whirlpools already remember the rhythm of the beginning. The song has faded, but the dance continues. It means that spin is not something galaxies gain later. It is woven into their birth. From the first breath of cosmic matter, rotation is an inheritance, passed down directly from the primordial currents that stirred the newborn universe. Spin is not an accessory. It is identity, shaping destiny from the first turn. But rotation does more than define a galaxy's form. It governs how galaxies live and die. Fast-spinning disks create order from chaos, guiding gas into stable circular orbits. In these calm lanes of motion, stars are born generation after generation, sustaining the galaxy's light for billions of years. Yet when galaxies collide, spin becomes a language of fate. Aligned spins merge in harmony, producing vast, majestic rotators, immense, whirling giants of light. But when their spins oppose, the meeting turns violent. Angular momentum cancels, turbulence rises, and star formation falters. Some galaxies fade not from age, but from discord. And once again, dark matter stands unseen, the silent conductor of the cosmic orchestra. Simulations reveal that halos of dark matter themselves spin, dictating the orientation, structure, and endurance of the luminous matter they cradle. The stars we observe trace the patterns written by invisible hands, following filaments of dark matter and the deeper pull of dark energy. Even the elegant spirals of galaxies like Andromeda or the Milky Way are only surface ripples upon far greater, unseen vortices that twist through the hidden fabric of the cosmos. What makes this revelation beautiful is its universality. The same equations that describe a hurricane on Earth describe a galaxy, a cluster, a supercluster, all bound by the same principle of rotation. Spin is stability amid chaos, the quiet counterforce that prevents collapse and gives shape to existence. From the smallest cloud to the largest structure in the universe, rotation is the geometry of survival. So when you look at a spiral galaxy, its arms curling gracefully around a radiant core, what you're seeing is motion made visible, the frozen music of physics as old as time itself. Every curve, every orbit, every shimmering arc is a note in the great harmony of spin. And though we capture it in equations and telescopes, its essence is simple. The universe is not built on stillness, but on eternal turning, a quiet, endless rotation that holds it all together. Every spin, however, is temporary, not because it fades, but because it is shared. No galaxy exists alone. They drift through the universe like dancers in an immense, crowded ballroom, their steps guided by invisible threads of gravity. When two galaxies meet, their spins begin to converse. Collisions between galaxies may look catastrophic, but they unfold in slow motion. Millions of years of graceful, gravitational choreography. From afar, it can seem as though they simply pass through one another, their stars rarely striking head-on. Yet beneath that quiet illusion, their motions intertwine. Gravity stretches them into luminous ribbons, their spiral arms pulled into long, glowing bridges. What appears as destruction is, in truth, transformation. In these vast interactions, spin is rewritten. A galaxy's angular momentum can double, divide, or even reverse depending on how it meets its partner. When two disks rotate in the same direction, their spins merge smoothly, forming a single massive, fast-spinning spiral or lenticular system. But when they collide in opposition, their ordered motion unravels. The result is a rounder, slower, elliptical galaxy, a quiet monument to chaos resolved. Astronomers call this process violent relaxation, a poetic irony for something that ends in stillness. Yet even then, motion never dies. The debris of collisions does not vanish, it redistributes. Streams of gas condense into new spinning disks. Some settle into rings, others twist into polar structures that orbit at right angles to the old plane. Angular momentum remains eternal, never destroyed, only reimagined. Our own Milky Way bears these scars. It is not a solitary creation, but a mosaic, built from dozens of smaller galaxies consumed across billions of years. Astronomers can still trace the fossil trails of those ancient mergers. Ribbons of stars arcing across the halo, moving in ghostly unison, remnants of devoured worlds. Even now, the Milky Way draws in the Sagittarius dwarf galaxy, stretching it into a luminous band that wraps around the night sky like a forgotten memory of motion. And far ahead, another great encounter awaits. In roughly 4 billion years, the Milky Way and Andromeda will collide. Their central black holes will spiral toward one another, dragging entire constellations into vast tidal arcs. Over ages beyond human imagining, they will merge into a single colossal elliptical galaxy, already named Milky Way. The spiral arms that shape our skies will dissolve, but their rotation will not vanish. The combined spin of both galaxies will survive, redistributed, reborn in a new form. What looks like an ending is really a renewal, a recycling of motion. Every galactic collision mixes angular momentum like paint on a cosmic palette. The result is messy, chaotic, and beautiful. New shades of structure emerging from turmoil. It is through this constant blending that the universe avoids stagnation. Spin ensures continuity. Every generation of galaxies inherits the momentum of its ancestors. Their rotations pass down like ancient memory. Even within these collisions, creation continues. As galaxies merge, their gas is funneled inward, collapsing toward the heart. There, new stars blaze into being, while sleeping black holes awaken. Fed by infalling matter, they spin faster, transforming rotational energy into colossal jets that pierce space for hundreds of thousands of light years. These jets regulate the birth of new stars. Too much energy, and star formation halts. Too little, and chaos resumes. Spin gives rise, then restrains. It is both creation and control, a feedback loop as elegant as it is violent. The quiet turning that began at the dawn of time still echoes in every orbit, every galaxy, every breath of light, the eternal pulse of a universe that never truly stands still. It is humbling to realize that even chaos obeys law. Every distorted spiral, every luminous bridge stretched between colliding galaxies, every arc of starlight is not disorder. It is the signature of angular momentum at work. Spin does not fight gravity, it balances it. Gravity hungers for collapse, while rotation resists, turning that fall into dance. Even when galaxies crash and twist, spin adapts, transfers, endures. Collisions are not wars, but conversations. Exchanges of motion that write the next chapter in the universe's story of rotation. And yet, behind this majestic turning lies a deeper mystery. The visible matter, stars, gas, dust, is not enough. By every measure of Newton's laws, galaxies should tear themselves apart. Their outer stars spin too fast, racing at impossible speeds. The further one travels from a galaxy's center, the faster those stars orbit, defying expectation. If gravity came only from what we can see, they would fly off into the dark, flung away like sparks from a wheel. But they do not. Something unseen binds them, a hidden mass vast beyond imagining. We call it dark matter, a presence that neither emits, reflects, nor absorbs light. It does not collide, it does not glow, yet it outweighs the luminous universe by 5 to 1. Around every galaxy, it forms a vast invisible halo, stretching far beyond the reach of starlight. These halos are the anchors of creation, the quiet counterweights that let spin endure. Without them, every galaxy's rotation would be its undoing. Dark matter is the unseen structure that steadies the cosmic wheel. Astronomers first saw its imprint in the shapes of rotation curves, the way a galaxy's stars move in orbit. Instead of slowing down at the edges, as planets do around the sun, galactic stars maintain their speed. The rotation curve stays flat, a cosmic whisper that something massive and hidden holds them fast. This unseen gravity keeps the stars bound, the same way air pressure keeps a storm's column intact. It is the invisible tension that turns chaos into form. On larger scales still, dark matter is the architect of cosmic spin. In the universe's youth, before light could travel freely, these dark particles moved slowly, untouched by radiation pressure. They began to collapse long before ordinary matter cooled. In doing so, they traced the first filaments of the cosmic web, immense, invisible rivers of gravity that stretched across the universe. These filaments did not merely fall inward, they twisted, channeling angular momentum like currents of liquid stone. Ordinary matter, hydrogen, helium, and dust simply followed, pouring into these dark rivers and inheriting their motion. Every galactic spin we see today, from the smallest dwarfs to the grandest spirals, is the visible echo of those hidden vortices that began billions of years earlier. Computer simulations reveal this truth in haunting precision. When scientists model the cosmos without dark matter, the result is a universe that cannot turn. Galaxies fail to form, and the few that do cannot hold their shape. Their disks collapse or fly apart, their motions incoherent. Only with dark matter do the structures become real. Spirals emerge, arms stretch, rotation holds. Dark matter doesn't just allow galaxies to exist, it teaches them how to move. Even now, across the deep sky, galaxies remember the orientation of those ancient flows. Massive surveys like the Sloan Digital Sky Survey and ESA's Euclid mission map the rotations of millions of galaxies. And the pattern is not random. Their spins show faint alignments with the filaments of the cosmic web, as if they still remember the invisible rivers of dark matter that birthed them. It is a memory written in motion, a gravitational inheritance that has lasted for more than 13 billion years. Dark matter, then, is not a silent bystander. It is a dynamic participant, a hidden field that spins back. Some physicists believe its nature is inseparable from rotation itself. If dark matter is composed of ultralight particles, perhaps axions, they could form macroscopic vortices, swirling condensates that turn across entire galaxies. Others imagine particles with intrinsic spin, subtle quantum twists that shape how galaxies align, merge, and evolve. Whatever its true form, its fingerprints are everywhere. In every spiral arm, in every stable orbit, in every galaxy that refuses to fly apart, the evidence of dark matter's hand is clear. It is the unseen harmony beneath the universe's dance. Without it, rotation could not persist. The spirals would unravel, the stars would scatter, and the quiet balance between motion and gravity would collapse. Dark matter does not simply permit spin, it preserves it. It gives the universe the framework it needs to turn and the strength it needs to endure. Gravity may pull everything inward, but dark matter steadies the fall, allowing rotation to survive. Together they compose the great equilibrium, collapse and resistance, weight and motion, the eternal duet that keeps the cosmos turning. The universe's vast choreography depends on dancers we cannot see, moving through a stage of darkness beneath the thin veil of light. It humbles us to know that almost everything shaping the cosmos lies beyond what our eyes can reach. The motions that sculpt galaxies, the balance that lets them endure, are written not in light, but in shadow. What we call dark matter forms the unseen platform upon which the luminous universe performs, while dark energy, the strange pressure that stretches space itself, may be the rhythm that drives the entire performance forward. If we could somehow step outside the universe and watch it unfold from afar, we would not see chaos, we would see rhythm, a vast cosmic dance choreographed across billions of light years. Galaxies are not scattered like grains in the void. They weave together along invisible filaments of dark matter, forming the intricate lattice astronomers call the cosmic web. At the intersections of those filaments, clusters of galaxies rotate around shared centers of gravity. Every spiral, every elliptical, every arc of motion follows a deeper pattern. The universe is not random. It is composed like a symphony of motion, with gravity as its conductor and angular momentum as its music. The alignment of galaxy spins across this web reveals that these colossal systems do not rotate in isolation. Their spins tend to align with the very filaments they inhabit, as though they feel the pull of a larger current, a cosmic tide. It's as if the entire universe inherited a faint rhythm from its earliest turbulence, a whisper left over from the moment after inflation, when the first ripples of motion passed through the primordial dark. Modern sky surveys, from the Sloan Digital Sky Survey to the Euclid and DESI missions, now map millions of galaxies, measuring not only their positions but the directions of their spins. What emerges is astonishing. Galaxies at the edges of filaments often rotate along those threads, while those deep in dense clusters tend to spin perpendicular to them. It is as though the universe is slowly winding itself like an immense screw, converting energy and matter into an organized architecture of rotation. This is more than poetry, it's physics on the grandest scale imaginable. The same tidal torques that once gave individual galaxies their spins also twisted the vast filaments of dark matter. As matter flowed inward, those filaments twisted back, embedding a preferred direction into the fabric of the cosmos. Galaxies that later formed within them inherited that ancient spin, like leaves caught in a turning current. The result is a universe that not only expands but also rotates, subtly, collectively, with gravity and time as its sculptors. Even light remembers this hidden symmetry. The polarization of photons from distant galaxies, stretched thin by the expansion of space, carries a delicate imprint of ancient rotational flows. By studying those polarization patterns, astronomers can trace the first cosmic vortices that spun through the infant universe. The cosmos remembers its first turns, and that memory is still written across the sky. If we could speed up time, condensing billions of years into moments, we would see the great web alive with motion, filaments twisting, clusters merging, galaxies spinning like musical notes in a rising crescendo. Space itself would expand to the steady tempo of dark energy. Gravity would provide the heartbeat. Dark matter would be the deep bass line holding it all together, while galaxies, glowing, fragile, temporary, would shimmer as the melody. The entire universe would move like a symphony built on invisible physics, each layer harmonizing with the next. Astronomers call this phenomenon cosmic coherence. It isn't mysticism, it's mathematics. Across scales vast and small, the same laws of motion apply. The spin of a particle, the orbit of a planet, the rotation of a galaxy, all are part of the same grand pattern. Over billions of years, gravity has not created randomness, but resonance, repetition, and rhythm. Perhaps that is the most elegant truth the universe offers. Order and motion are not opposites, but companions. Each rotation, each orbit, each vibration adds its own note to a timeless composition. When we gaze through our telescopes and capture the light of galaxies billions of years old, we are not just looking into the past. We are witnessing the rhythm of creation itself, a silent symphony still playing the song that began with the very first spin. The universe has always turned, but one day, rotation took new form, in atoms that spun with charge and energy, in molecules that danced through chemistry, in worlds that began to breathe. Long before oceans stirred or life emerged, the same cosmic rhythm was already shaping the invisible architecture of matter. Nothing has ever truly been still. Their electrons spin, not as metaphor, but as truth, each particle carrying within it a tiny magnetic heartbeat, a pulse of motion that never stops. Spin is a built-in property of matter, a whisper from the quantum realm that gives every atom its restless soul. From that motion, chemistry itself is born. When two electrons spin in opposite directions, they pair, binding together in harmony, forming the stable bonds that make molecules. When their spins align, they repel, creating magnetism and division. Every structure in your body, every cell, every strand of DNA exists because of this microscopic dance between attraction and resistance, symmetry and imbalance. Yet the story deepens when we turn to chirality, the handedness of molecules. Some molecules come in two mirror versions, one left-handed and one right-handed, identical in chemistry, but incompatible in life. Your amino acids, the foundation of every protein in your body, are all left-handed. Your DNA spirals only to the right. This universal bias, this quiet molecular preference, remains one of the deepest mysteries of biology. Why does life favor one spin over the other? In laboratories, when scientists create amino acids from scratch, they appear evenly, left and right in perfect balance. But nature does not. Every living cell obeys one direction, one twist, as if chemistry itself remembers a primordial decision the universe once made. Some believe that decision was written in starlight, polarized light from newborn stars, or the powerful magnetic fields of dying supernovae may have destroyed one molecular orientation more easily than the other, leaving a cosmic surplus of left-handed building blocks drifting through interstellar clouds. Meteorites like the famous Murchison stone, older than Earth itself, carry amino acids that share this same bias. The seeds of life's asymmetry may have fallen from the spinning clouds of the early cosmos. Others look deeper still, into the fundamental forces of nature. In particle physics, the weak nuclear interaction, one of the universe's most basic forces, already breaks mirror symmetry. Only left-handed neutrinos exist. It is as if nature itself, from its earliest breath, preferred a single orientation. Perhaps that subtle quantum prejudice echoed upward through the hierarchy of creation, from particle to molecule, from chemistry to biology, until life simply followed the direction that physics had already chosen. Whatever the origin, the result is extraordinary. Life is not balanced. It is biased, and that bias gives it direction. A mirror Earth made from right-handed amino acids and left-handed sugars would look identical from space, but its biology would be alien. Its enzymes would not work, its DNA would not bind, its proteins would not fold. Even the smallest reversal in the molecular twist would halt the machinery of life. Once again, rotation becomes destiny. From galaxies to genes, spin separates what can exist from what cannot. Our very existence rests upon this faint cosmic preference, an ancient whisper of a symmetry that began long before the first cell divided. The DNA double helix, that elegant spiral carrying the code of life, is not merely a symbol of creation. It is a monument to motion, a frozen memory of the universe's earliest rotations, translated into the language of biology. Every twist of the helix is an echo of cosmic spin, a reflection of the same symmetry that shaped galaxies. Perhaps this is the secret poetry of existence. Life did not invent motion, it inherited it. Every world turns, but not every world awakens. The difference lies in what that spin creates. Beneath our feet, far below the crust and mantle, lies another spinning miracle. A molten heart of iron and nickel, roiling in endless convection. The Earth's core churns like a slow ocean of fire, driven by heat from its formation and by the planet's own rotation. From this restless motion emerges a silent guardian, the magnetic field. This field is alive, not static. As molten metal moves, charged particles create electric currents, which in turn generate magnetic forces. The planet's spin gathers these threads into a single, unified shield, the geomagnetic dynamo. It is one of the most elegant self-sustaining machines in the cosmos, a generator powered purely by motion. Without it, Earth would be defenseless. The solar wind, a ceaseless stream of charged particles from the sun, would strip our atmosphere away, grain by grain. Every flare, every coronal eruption would erode the sky itself. Yet because our planet spins, it endures. The auroras that shimmer across the polar night, those veils of green and crimson light, are more than beauty. They are the glowing edges of Earth's magnetic armor, the visible scars of a planet that spins fast enough to keep its breath. From the smallest electron to the turning of the Earth, from the swirl of galaxies to the spiral of DNA, motion has been the universe's language since the beginning. Every rotation, every twist, every magnetic pulse is a syllable in the same story. A story that began with the first spin and still continues in us. We don't have to imagine a world stripped of its magnetic shield. Mars already tells that story. Once the red planet pulsed with motion beneath its crust. It had a molten core, a spinning heart of metal that generated a magnetic field, just as Earth's does now. For a time, it too was wrapped in an invisible armor against the solar wind. But as the small planet aged, its core cooled, its dynamo stilled, and the shield dissolved. Then came the sun's relentless breath, streams of charged particles sweeping across its surface, stripping the atmosphere molecule by molecule into the void. What remains is a cold and silent desert, where dry riverbeds trace the memory of vanished oceans. Mars still spins, but it no longer spins deep. Its heart has stopped turning. Jupiter, in contrast, is all motion, a vast storm of hydrogen and rotation. Deep within its immense pressure, hydrogen becomes metallic, a conductor of electricity on a planetary scale. Combined with Jupiter's rapid 10-hour spin, it creates a magnetic field so powerful it could engulf 15 Earths. Radiation belts coil around it like serpents of light, while auroras blaze at its poles, hundreds of times brighter than our own. It is the purest expression of rotation's power, where motion sculpts invisible architecture and light itself bends to the rhythm of spin. Even the moon bears quiet traces of this cosmic heartbeat. Long ago, it too generated a weak magnetic field, powered by tidal interactions with Earth. But as its core cooled and motion slowed, the field faded. What remains are ghostly magnetic imprints frozen into ancient crust, fossils of an extinct dynamo, echoes of a world that once turned with more life. Earth, though, still breathes. Every rotation keeps its molten core in motion, sustaining the magnetic cocoon that makes life possible. And that shield does far more than deflect radiation. It stabilizes our skies, shapes animal migrations, and guards our technology. Every compass needle, every satellite orbit, every GPS signal quietly traces the same invisible lines of force, born from the churning metal beneath our feet. It's humbling to realize that our survival depends not on something we can touch or see, but on motion, the silent turning of iron and fire thousands of miles below us. Spin gave us chemistry, spin gave us magnetism, and together they gave us a home that endures. So when you stand beneath the dancing aurora, when green light ripples across the polar sky like a living veil, remember what you are witnessing, proof that the planet is still alive inside. Deep within its heart, the universe's oldest rhythm continues. The rhythm of rotation, steady and patient. Not too fast, not too slow. Our world turns once every 24 hours, an ordinary miracle that defines everything. But that pace is not random. It is the perfect balance. Slow enough for life to breathe, fast enough to hold its shield. Had Earth spun faster, days would shorten, and winds would tear across the continents with violent force. Oceans would bulge toward the equator, flooding coastlines, while polar regions would dry and crack. The air itself would race in wild bands, splitting climates apart. Mountains would erode faster, storms would rage longer, and gravity at the equator would weaken, just enough to unweave the balance of sea, sky, and soil. If Earth spun more slowly, the danger would reverse. Days and nights would stretch for weeks. One hemisphere would bake under unending daylight, while the other froze in darkness. Winds would falter. Oceans would fail to carry warmth across the globe, and the fragile rhythm of temperature and light that nourishes life would collapse. The 24-hour day is not a coincidence. It is the result of eons of cosmic adjustment. When Earth first formed, it spun wildly fast. A day lasted only 6 hours. But the pull of the moon, constant and patient, has acted as a celestial brake. Tidal friction, the rising and falling of oceans, steals tiny fragments of Earth's rotation, converting motion into heat. Each century, our planet's day grows longer by 2 milliseconds, almost imperceptible, yet relentless. In time, our descendants will live beneath a slightly slower sky, their world turning more gently than ours. That slowing has been a blessing. It stabilized the crust, tamed the seas, and gave the magnetic dynamo time to thrive. Too fast, and the planet would have torn itself apart. Too slow, and its core would have frozen early, ending the magnetic shield that keeps us safe. Somewhere between those extremes, Earth found the perfect rhythm, a spin that endures, a balance between chaos and stillness, a rotation that keeps the core alive, the air intact, and the sky shimmering with light. The auroras above are not just a spectacle. They are the breath of a living world, the proof that deep below us, the heart of Earth still turns in time with the universe's oldest song. But this middle ground, this just right spin, is what gives us both climate and protection. It creates rhythm, predictability, and grace. The turning of Earth sets the tempo for every breath of wind, every drop of rain, every rising and falling tide. Day and night, wake and sleep, all unfold to the same ancient beat. Spin became the invisible metronome of life, and everything that lives learned to dance to it. Every creature on Earth, from single-celled bacteria to blue whales, carries a memory of that rotation deep within its chemistry. Inside our cells, molecular clocks keep perfect time with the rising and setting of the sun, guiding when we eat, rest, heal, and dream. These circadian rhythms are not arbitrary. They are the biological echo of the planet's daily spin. If the Earth turned faster or slower, the rhythm of our chemistry would have been different. It is as though the planet's rotation wrote itself into our DNA, engraving motion into the very fabric of life. Each sunrise resets this clock. Each sunset reminds us that the universe turns, and we turn with it. Astronomers speak often of the habitable zone, the distance where liquid water can exist. But there is another quieter zone, the rotational habitable zone. A planet may orbit at the perfect distance from its star, yet still be barren if its spin is too fast or too slow. Rotation defines not just time, but balance. Earth's rotation, its tilt, and the steady pull of the moon create a harmony few worlds enjoy. Together, they prevent chaotic wobbling, keep the seasons steady, and sustain the stability that allowed complex life to flourish. It is a partnership of gravity, motion, and chance. 4.5 billion years in the making, that produced a world that turns just right. When the horizon brightens each morning, it is not simply the result of motion, it is the proof of balance. The fine-tuned spin that lets oceans breathe, clouds drift, and hearts beat. Our planet's gentle rotation is not a trivial detail. It is the perfect imperfection that lets life endure. Life on Earth does not merely exist within time. It was built by it. From the first living cell to the first spark of consciousness, every being that has ever lived has done so under the slow metronome of a turning world. The Earth's rotation, its axial tilt, and its orbit around the sun, these are not random mechanical motions. They are the cosmic pulses that shaped biology itself. When life began, Earth spun faster. A day lasted only a few hours. The oceans were caught in eternal twilight, blistering heat by day, freezing darkness by night. In this world of extremes, primitive cells learned to adapt, developing chemical rhythms that told them when to shield themselves and when to divide. Those early molecular cycles, mere chemical reactions, at first evolved into the circadian clocks that still guide every living thing, even bacteria, possess them. Microscopic loops of genes and proteins that oscillate with astonishing precision, echoing the planet's 24-hour rhythm. In plants, these clocks tell leaves when to open, stems when to climb toward the light, and flowers when to release their pollen. In animals, they regulate sleep, temperature, and hormones. And in humans, they conduct nearly every process within us, from the firing of neurons to the repair of DNA. The planet's spin became the silent conductor behind life's universal rhythm. But the influence of rotation reaches beyond the daily cycle. Earth's axial tilt, about 23.5 degrees, is what gives us seasons. The long alternation of warmth and cold, abundance and scarcity. That tilt has sculpted evolution for hundreds of millions of years. The migrations of birds, the hibernation of mammals, the blooming of forests, even the waxing and waning of ice ages, all trace their roots to this gentle lean in the planet's posture. It is an imperfection that grants diversity, forcing species to adapt, to move, to evolve, or to vanish. And in the fossil record, we can still see this planetary pulse preserved. Ancient corals, layered like tree rings, carry the marks of time itself. Their skeletons record the number of days in a year long past, showing that Earth's rotation has been slowing gradually for eons. Hundreds of millions of years ago, a year held more than 400 days. The planet turned faster then, and life beat to a quicker rhythm. Over time, the moon's gravitational pull stretched that spin into the gentler pace we know today. A slowing that became stability, a balance that became home. That means shorter days, faster rotation, and quicker biological rhythms, a heartbeat of evolution once set to a faster drum. Over eons, life has slowed in step with its planet, adjusting its tempo to the steady deceleration of Earth's spin. Even the moon, our silent companion, has shaped that rhythm. Its gravitational pull steadies Earth's tilt, moderates the seasons, and stirs the tides that first cradled life. Every rise and fall of the sea whispered time into the minds of primitive creatures. In the rhythm of waves and planetary turning, cells learned coordination. Muscles learned to ripple, hearts learned to beat, lungs learned to breathe in pulses. Even our deepest biological cycles echo the slow pull of the moon and the steady spin of Earth beneath it. If evolution is a story of adaptation, then time is the ink, and spin is the hand that writes. The cycles of day and night, summer and winter, tides and seasons. These are not mere settings for life's story, but the script itself. Some scientists now believe that intelligence, the ability to anticipate and plan, arose from the need to predict these recurring changes. To survive, organisms had to sense pattern, to know when to hunt, to hide, to rest, to wait. In learning to foresee the turning of the world, they learned the essence of thought. Consciousness, in this sense, may be a byproduct of rotation. Awareness born from rhythm, memory born from motion. The planet spins, and through that motion it teaches everything upon it to move, to adapt, to remember. The pulse of Earth is not measured only in its rotation, but in the living systems that keep time with it. Every sunrise resets evolution's clock. Every sunset prepares the next act of creation. And when we close our eyes each night, we return to that same rhythm that began 4 billion years ago. The steady, ancient turning of a world that spins just right. Yet every motion has a cost. Every spin, no matter how vast or delicate, yields to time. The universe itself was born in motion. Space expanding faster than light. Matter collapsing into stars. Galaxies spiraling like cosmic wheels. But energy spreads. Order erodes. The same laws that gave rise to motion ensure it cannot last forever. Angular momentum is conserved, but energy, once dispersed, cannot be reclaimed. Friction, radiation, and gravity each steal a little from the cosmic dance. Stars slow as they shed their mass. Planets drift as they trade angular momentum with their moons. Galaxies stretch and bleed their spin into tidal streams that trail across space. Even on the largest scales, the expansion of the universe is a racing rhythm, diluting the cosmic tempo. Our own planet bears quiet witness to this great unwinding. With each century, Earth's rotation lengthens by mere milliseconds. Tidal friction transfers angular momentum to the moon, pushing it slightly farther away, a few centimeters each year. 1 billion years from now, a day on Earth will last 30 hours, and the moon will hang smaller in the sky, a pale, distant clock marking the slowing of our world's heartbeat. The sun, too, is aging, and its spin fading. Its magnetic field drags against charged particles in the solar wind, bleeding angular momentum into interplanetary space. Astronomers call this magnetic braking, the slow surrender of stars to time. By measuring a star's rotation, they can read its age, a science known as gyrochronology. The slower the spin, the older the star. Even the cosmos keeps its calendar through the measure of turning. On the scale of galaxies, collisions act as brakes. Each merger redistributes angular momentum, converting graceful rotation into chaos. Spirals, once elegant and youthful, collide and blur into amorphous ellipses, ancient, lumbering remnants of their former grace. These elliptical galaxies, pale and swollen with age, no longer spin with youthful speed. They are the retired dancers of the universe, their motion spent, their rhythm replaced by stillness. But the greatest deceleration of all lies not in stars or planets, but in the fabric of space itself. As dark energy stretches the cosmos ever outward, gravity weakens and clusters of galaxies drift farther apart. The exchange of angular momentum between them dwindles, their connections thinning, their motion slowing. The cosmic web, once taut with tension, is loosening. Its filaments relax. Its vast geometry softens under the pull of eternity. One day, far beyond all human imagining, when the last stars fade and the galaxies cool to ash, the universe will enter its quietest age. Rotation will persist but faintly. Black holes will turn in the dark, their event horizons slowly eroding. Atoms will tremble with the last traces of heat. Each motion will be slower than the one before, each revolution longer, until entropy completes its infinite work. It is tempting to call that the death of motion, but it is not death, it is transformation. The energy that once built stars and spun galaxies will have diffused into the fine mist of space-time itself. Spin will not vanish, it will dissolve, a final surrender of order into balance, of rhythm into stillness. The universe will keep turning, not in circles, but in memory, the echo of all that once moved, the afterglow of a cosmos that once spun itself into being. Its legacy remains etched in the very geometry of the cosmos, a faint curvature pressed into the fabric of space-time by everything that has ever moved. Even when the last motion fades, the trace of its dance endures. In that way, nothing that ever turned will ever truly stop. The universe may slow, but it will never forget how to move. For billions of years, the stars have spun in quiet defiance of entropy, fueled by the nuclear fire at their hearts. Hydrogen becomes helium, helium becomes carbon and oxygen, and in that chain reaction, the building blocks of life are born. But every spark has its cost. Every fusion steals a fraction of the brilliance that keeps the cosmos alight. As the stars age, their rotation softens. The fierce equilibrium that once held their balance falters. When a sun-like star reaches the end of its fuel, it exhales its outer layers into the void, revealing a dense glowing ember, a white dwarf, no larger than Earth yet bearing half the sun's weight. It spins more slowly now, cooling over trillions of years until its light fades completely. Then only a black dwarf remains, a silent relic in a universe that remembers its warmth. The giant stars die differently. Their cores implode under the unbearable weight of gravity, spinning faster and faster as they collapse, like a skater pulling their arms inward one last time. Atoms disintegrate. Electrons and protons merge into neutrons, forging a body so dense that a single teaspoon of its matter outweighs a mountain. These are neutron stars, tiny, furious worlds no wider than a city, spinning hundreds of times per second, their magnetic poles firing beams of light across the cosmos. We call them pulsars, dead stars that still speak, their rhythmic pulses marking the heartbeat of time itself. But even they cannot defy eternity. Their spin slows, their voices dim, their beams fade into silence. Gravity gathers what remains, and once again the universe folds inward. A black hole is born, a region where space curves so deeply that not even light can escape. Yet even here, the story of motion continues. Black holes spin too, twisting space and time around them in spirals of gravity that never unwind. Their rotation sculpts the shape of space-time itself, dragging everything near into a vortex of eternal motion. Some black holes whirl at more than 99% the speed of light. Their stored rotational energy can launch jets of plasma across galaxies, rivers of fire stretching millions of light years, powered by the final reserves of the universe's spin. They are the last dancers in the cosmic waltz, silent engines keeping time in the dark. But even these titans fade. Stephen Hawking's insight revealed their secret erosion. Hawking radiation, a faint whisper of quantum energy slowly draining their mass and their motion. Over unimaginable ages, their spin weakens. Eventually, they too evaporate, turning once more one last revolution in the silence before dissolving into pure light. By that age, the universe will have grown vast and cold. No stars, no warmth, only drifting remnants in a sea of black. Yet even in that perfect stillness lies a kind of grace, a symmetry that reflects the beginning. The same laws that ignited the stars ensure their motion will never truly vanish. Energy transformed, spin remembered, time preserved. The lights will go out, but the memory of their turning, the cosmic rhythm born in the first moments, will echo through space-time forever. And perhaps, if the universe could dream, it would not remember its light, but the feeling of having once been in motion, the soft hum of turning, the endless rhythm of becoming. In the end, everything slows, every star fades, every atom drifts apart. The universe will not die in fire, but in silence. When the final black holes evaporate and their last whisper of Hawking radiation dissolves into the dark, no warmth will remain, no light, no gravity strong enough to shape movement again. Space will keep expanding, vast, cold, and almost empty, until even distance itself loses meaning. Yet even then, spin will linger, not as motion but as memory. Space-time will still recall the vortices that once stirred it, the galaxies that once spiraled in luminous grace, the particles that once danced to unseen rhythms. Their patterns will remain imprinted upon the geometry of reality, a fossil record of motion in a universe that no longer moves. This is the heat death, the final equilibrium, the silence after the last note. Entropy reaches its summit. No gradients remain to drive change. No imbalance to sustain rotation. Every orbit decays, every temperature evens, every system settles into stillness. The cosmic symphony ends and silence claims the hall. Yet even here the laws endure. Angular momentum is not destroyed, only spread thin, diffused across infinities so immense they escape meaning. Like a melody stretched beyond recognition, the rhythm of spin fades not through death, but through dispersal. Some physicists imagine that in this quiet void, tiny fluctuations will still ripple through the vacuum, brief tremors in space-time, fleeting loops of creation and collapse. From one of those ripples, a new universe might emerge, its expansion kindled by the same instability that once gave birth to ours. If that moment comes, the first motion of that newborn cosmos, the first spin, the first turning, will not be truly new. It will be an echo, a continuation of this one. Perhaps that is the secret of creation. There is no final stillness, only pauses between movements. Spin never dies. It only changes scale. And if some distant consciousness could witness that final age, it would see not tragedy, but continuity. The unbroken rhythm of existence. Every orbit, every revolution, every flicker of motion was a note in a single, infinite composition. From atoms to galaxies, the universe spun itself into being, and one day, it will spin itself into rest, gracefully, inevitably. The last rotation may never be seen or measured, but it will happen quietly, beautifully, the final gesture of a cosmos that was born to turn, for nothing that ever moved is ever truly gone. Even when the universe falls silent, motion leaves behind a memory, written into matter, encoded in form, carved into the invisible architecture of everything that remains. Every atom within you remembers it. The iron in your blood was forged in the furnace of a spinning star. The calcium in your bones was born in the collapse of a supernova, hurled into the void by rotational fury. The molecules of life, DNA, proteins, cells, all bear the mark of motion. A twist, a spiral, a rhythm. You are made of memory. You are made of spin. Every breath, every heartbeat, every flicker of thought is a tiny echo of the universe's ancient turning. The swirl of galaxies, the pulse of a neuron, the orbit of an electron. All are expressions of the same endless motion. There has never been stillness, only continuity. Perhaps that is why consciousness feels like movement, flowing, folding, reflecting, looping, remembering. Every idea is a kind of rotation, matter turning inward to think about its own motion. We are the universe observing its own spin, the mind of motion itself. And as we look outward, past our skies, past our stars, past even time, we find that everything still turns. Electrons around nuclei, planets around stars, stars around galaxies, galaxies around the invisible bones of dark matter. Every scale, every structure, every breath of existence follows the same ancient pattern. Even when the lights go out, the pattern remains, the eternal fingerprint of spin, pressed into the fabric of space-time, the final memory of motion in a universe that never truly stopped turning. And so, when the final particle stops moving, if such a thing could ever truly happen, perhaps the universe will remember, not in sound or sight, but in symmetry, the faint echo of everything that once turned. Maybe that is what it means to exist, to move, to leave an imprint, to become part of a larger rhythm. The cosmos began as motion, a ripple, a vibration, a single breath. And from that first act of turning, all form emerged. We are not separate from that motion. We are its continuation. When we look up and feel something stir at the sight of a spiral galaxy, it is recognition, not in thought, but in resonance. The universe spins, and so do we. Long after we are gone, long after the last stars fade, the memory of motion will endure. At the end of every journey, we return to the beginning, but see it for the first time. The universe began with motion, a flicker of imbalance, a twist in a sea of stillness. And from that twist came direction, and from direction, time. Everything that followed, stars, atoms, life, thought, was born from that first turn. Now, after billions of years, that motion is scattered into countless forms, some vast as galaxies spiraling across the cosmic web, others small as electrons spinning within your body, yet each one is connected, threads of a single unfolding spiral that has never stopped. Perhaps this is how the universe remembers, not in words, not in human memory, but through persistence, through the refusal of motion to end. Every orbit, every rotation, every flicker of change is a reminder that the story continues. We are the universe looking back at its own movement. Our curiosity, our longing to understand, is not apart from the laws that made us. It is those laws, matter reflecting on motion, energy wondering where it came from. Maybe that's why the question, why does everything spin, feels so profound, because hidden inside it lies another. Why do we? Why do we move, learn, search, create, turning endlessly toward meaning, as if trying to align with something vaster than ourselves? Across every galaxy, every atom, every heartbeat, the answer is the same, because spin is existence. Without it, there would be no time, no structure, no being. It is the gesture that keeps reality from collapsing into silence. And if you could gaze beyond the final stars, beyond the last black hole, into the darkness after time, perhaps you would still sense it. A faint pulse, a quiet rhythm, the echo of the universe remembering itself, a whisper carried through eternity. I was motion, I became matter. I dreamed of life, and through life, I learned what I was. And when our own consciousness dissolves back into that cosmic sea, the universe will turn again. Not as a beginning, but as continuation. The circle will close, the silence will breathe, and in that breath, everything will move once more. Time feels simple. The sun rises, the sun sets, days flow into nights. We build our lives upon that gentle rhythm, but beneath this simplicity lies an invisible force, relentless, ancient, that makes everything we know possible. That force is spin. Even now, the earth turns beneath your feet. A silent motion carrying us through space at more than 600 kilometers per hour at the equator. You do not feel it, but it shapes everything. It gives us the cycle of day and night, the rhythm of now and later, the heartbeat of time itself. If that spin changed, even slightly, our world would change with it. Shorter days, longer nights, skies that move too fast or too slow. And if the earth ever stopped spinning, time as we know it would shatter. But this story is not just about our planet. From the smallest particles to the largest galaxies, everything in existence turns. Stars spin, planets spin, black holes spin so violently they drag space and time in their wake. Even the tiniest building blocks of reality, subatomic particles, possess spin, a property so fundamental it shapes the universe at every level. And here lies the deepest mystery. Spin does not merely mark the passage of time. It bends it, stretches it, sometimes even stills it. To follow the story of spin is to trace the hidden clockwork of reality, from the turning of planets to the twisting of quantum fields, from the first cosmic swirl to the last fading rotation. Because in truth, time does not rule spin. Spin rules time. And from the first breath of creation to the final whisper of entropy, everything that ever existed, everything that ever will exist, is just the universe remembering how to turn. It never truly stops. That's the quiet law of angular momentum, the hidden rhythm of motion that refuses to fade. It's what measures how much spin a system carries, how deeply it clings to movement. When nothing interferes, angular momentum is conserved. It stays, it endures. That's why a spinning top keeps turning long after it's set in motion. Why a figure skater spins faster as their arms draw in. Why stars, planets, and entire galaxies continue their endless revolutions long after their birth. But where does this cosmic spin begin? The answer lies in the first breaths of the universe itself, when vast clouds of gas and dust began to collapse under gravity's pull. These clouds were never perfectly still. Even the tiniest flicker of motion was enough. As they shrank, that motion was amplified, like an ice skater pulling in their arms, spinning faster and faster. And from that elegant rule, the universe began to turn. Stars igniting, galaxies swirling, planets dancing endlessly through the dark. Spin was never an accident. It was a consequence, inevitable, unstoppable, born from the marriage of gravity and motion. And once created, it almost never disappears. Collide two spinning worlds, and their momentum doesn't vanish. It merely redistributes, reshaping itself into new forms of rotation. On Earth, we live inside the consequences of that ancient spin. Our atmosphere swirls because the planet turns. Ocean currents spiral around invisible axes. Storms twist into hurricanes, their fury born from the Coriolis effect, a direct child of Earth's rotation. But our planet is only one small player in this grand spinning symphony. From the smallest asteroid to the largest black hole, everything turns. Spin is one of the universe's most universal signatures. And strangely, it's also the key to why time itself doesn't flow evenly everywhere. Because when rotation grows intense enough, time begins to warp. Spin something fast enough, and you don't just move it, you bend the very fabric of time. It sounds impossible, but it's one of the most profound discoveries in physics. The faster an object moves, the slower time flows for it. This isn't a thought experiment. It's the real consequence of Einstein's theory of relativity. And spinning objects let us see that truth most clearly. Imagine two identical clocks. One rests perfectly still on the ground. The other is strapped to a ring spinning at immense speed. To the spinning clock, nothing seems unusual. Its seconds tick as always. But when the two clocks are compared later, the spinning one has counted fewer seconds. Time has literally moved slower for it. This isn't just theory. It's been tested and measured. Atomic clocks on airplanes, satellites, even at different points on Earth, all tick at slightly different rates. Clocks near the equator, where Earth's rotation is fastest, move imperceptibly slower than those near the poles. The difference is microscopic but real, a quiet echo of relativity in motion. The reason is simple yet profound. Every point on a spinning body is moving through space. The faster the spin, the greater the velocity. And as velocity nears the speed of light, time begins to stretch and slow. If Earth spun much faster, people near the equator would age infinitesimally slower than those at the poles. Spin something near the speed of light and the difference becomes cosmic. A single day for that object could equal years to the rest of the universe. And this isn't just an exotic curiosity. Without understanding this time-warping effect, modern technology would fail. The satellites that make up our GPS system orbit Earth at incredible speed. Their clocks, ticking in that rapid motion, run differently than clocks on the ground. Engineers must correct for relativity, or the entire system would drift by kilometers each day. When things spin, they carry more than motion. They carry time itself, stretched and bent around their movement. The universe's rotations aren't just about motion, they're about time. And in every turning world, from the smallest grain of dust to the most massive galaxy, that ancient law continues. The quiet persistence of motion that even time must obey. Every rotation is more than motion through space. It's a quiet step into another timeline. Earth itself is part of that slow, endless ballet. With each turn beneath our feet, our clocks drift ever so slightly, slipping through a different rhythm of time. We rarely sense it, but every moment we live inside the gentle curvature of relativity. We like to think time is absolute, that a second is a second everywhere, that a minute always carries the same 60 beats. But that belief is an illusion born of perspective. On a spinning planet like Earth, time doesn't flow evenly. Every point moves through space at a different speed. At the equator, Earth whirls faster than 1,600 kilometers an hour. Near the poles, that motion nearly vanishes. To us, it seems meaningless, but to the fabric of time itself, the difference matters deeply. Einstein's special relativity tells us that the faster something moves, the more slowly its time passes, relative to something slower. That means a clock resting at the equator, racing faster through space due to Earth's spin, ticks ever so slightly slower than one resting near the pole. The difference is unimaginably small, billionths of a second each day, but it's measurable. Scientists have proven it with atomic clocks so precise they can detect shifts smaller than a trillionth of a second. Over time, the two clocks drift apart, the equatorial one running just a little behind, not because of mechanical failure, but because it lives in a subtly different slice of space-time, and it grows stranger still. Earth isn't perfectly round. It bulges at the equator, stretched by its own spin. That bulge means gravity. There is a touch weaker than at the poles. Under general relativity, gravity and time are woven together. Stronger gravity slows time. Weaker gravity lets it flow faster. So at the equator, two opposing effects are at play. Higher velocity slowing time, weaker gravity speeding it up. And together they carve a delicate balance in the planet's invisible clockwork. Right now, as you read these words, that balance is ticking beneath you. If you lived your entire life at sea level on the equator, you'd age just a few milliseconds less than someone who spent their life at the poles. You'd never feel it, but the universe would know. It would keep the score. These differences are so real, they must be corrected for in our most precise technologies. GPS satellites orbit Earth at tremendous speed, far from the planet's surface, where gravity is weaker. Their clocks tick faster than ours below, while their motion tries to slow them down. Engineers must constantly balance both effects, special and general relativity, just to keep your phone's navigation accurate. Without those adjustments, GPS readings would drift by kilometers each day, and the entire system would unravel. On a spinning world, there is no universal clock. Every latitude, every altitude, every orbit runs on its own version of time. Earth's rotation carves invisible layers of chronology around it, thin as light, delicate as tree rings in a cosmic trunk. We don't notice because we're spinning too. We're inside the motion, inside the illusion, and yet this is only the beginning. The faster the rotation, the deeper the distortion. On Earth, the effects are faint, a whisper in time, but across the cosmos, where stars and black holes turn at unimaginable speeds, the bending of time becomes something far greater. Until now, we've looked at how motion slows time through velocity, but nature hides something more haunting. When a massive object spins, it doesn't just move through space and time, it drags them along. This strange effect is called frame dragging, one of general relativity's most subtle and breathtaking predictions. In Einstein's universe, space and time aren't passive backdrops. They're flexible, alive, a fabric that bends, ripples, and twists around mass and energy. When that mass spins fast enough, it doesn't just warp space-time downward, it stirs it sideways, creating a slow whirlpool in the invisible structure of reality. Picture a heavy marble resting on a stretched sheet of rubber. It dips the surface and smaller marbles roll inward. Now imagine spinning that heavy marble. The surface doesn't just dip anymore, it twists. The smaller marbles no longer fall straight. They're pulled into a spiraling path, dragged by the spinning fabric itself. That's frame dragging, and it's not just an elegant equation, it's been measured. In 2004, NASA launched a remarkable mission, Gravity Probe B. 4 ultra-precise gyroscopes were placed in orbit around Earth, each one so sensitive it could detect a tilt of less than 100,000th of a degree. Their goal, to test whether Earth's rotation truly drags space-time around it. For over a year, they spun in silence, measuring the tiniest shifts in orientation. When the data came back, the result was clear. The fabric of space-time around our planet is indeed twisting, ever so slightly as Earth turns. The world beneath us isn't just spinning in space, it's stirring the very geometry of time. After years of measurement and analysis, the verdict was unmistakable. Yes, Earth truly drags space-time along with its spin. The effect is unimaginably small, but it exists. Our planet doesn't merely move through time, it pulls time itself, gently folding it into its motion. Now imagine that same phenomenon magnified beyond anything Earth could produce. Picture a neutron star, the collapsed core of a dead giant, compressing the mass of our sun into a sphere barely 20 kilometers wide. Its rotation twists space-time so violently that anything nearby is caught in a spiral, drawn in like water circling a drain. And beyond even that, there are rotating black holes, where frame dragging becomes furious and unrelenting. Around these cosmic vortices, space and time themselves are whipped into motion, torn and stretched into ribbons of rotation. If you could somehow hover near such an object, your sense of time would dissolve. You wouldn't need to move at all. Space-time itself would be moving around you. Here on Earth, we only feel the faintest whisper of this effect. But across the cosmos, frame dragging is not a whisper. It's an architect. It shapes the luminous disks that circle black holes, powers jets of energy that slice through galaxies, and influences the evolution of entire star systems. Spin does not merely exist within space-time. Spin reshapes space-time. Every world, every star, every fragment of matter in the universe carries its own rhythm. Some worlds turn slowly, tracing centuries between sunrises. Others spin so fast that a single day passes in the blink of an eye. Hidden within those rotations lies a profound truth. Each world measures time differently. Take Earth, our quiet benchmark. A full rotation gives us our 24-hour day. At the equator, the surface races eastward at roughly 1,270 kilometers an hour, enough to bend time just a little, though we never notice. The effect is microscopic, a faint shimmer in the river of time, but in the deeper reaches of space, that shimmer becomes a storm. Consider Jupiter, 11 times wider than Earth, yet spinning in less than 10 hours. Its equator rushes through space at almost 45,000 kilometers an hour. That speed flattens the planet, swelling its equator into a broad golden band, and it bends time far more strongly. Clocks at Jupiter's equator would tick just a little slower than those near its poles, or those floating free in deep space. Jupiter doesn't just turn, it drags time along for the ride. Then there are the stars, colossal furnaces whose rotations outstrip anything a planet could endure. Young stars, still forming from collapsing clouds of gas and dust, often spin hundreds of times faster than Earth. Their equators fling out ribbons of matter, glowing disks of plasma that extend for millions of kilometers. Time near such a star flows differently, drawn thin by gravity, stretched by speed. And when such a star dies, something stranger is born. The heart of the collapsed star condenses into a neutron star, an object no wider than a city, yet heavier than the sun itself. Conservation of angular momentum, the universe's unbreakable rule, forces it to spin faster and faster as it shrinks. Some of these remnants, called pulsars, rotate hundreds of times per second. Their surfaces move at a significant fraction of light speed. At those velocities, relativity is no longer subtle. It dominates. Time itself slows under the crushing weight of motion and gravity. If you could somehow stand on the surface of a pulsar, ignoring the impossibility of survival under its billion-ton gravity, a single second for you might stretch into many seconds for someone watching from far away. Near such an object, time and spin merge. One defines the other. Spin doesn't merely sculpt the shape of stars and worlds. It alters the way their moments unfold. Two identical clocks, placed in different gravitational fields, will tick differently if one is drawn into the vortex of a spinning mass. This isn't a theory, it's measurable reality. Across the universe, countless rotations keep time in their own language. Every spin is a beat. Every beat leaves its signature in the fabric of space-time. And the faster the spin, the slower the clock runs. There exists, however, a realm where spin reaches its ultimate expression, where gravity is absolute and rotation warps reality beyond recognition. Here, space and time collapse into a single churning entity, a spinning black hole. Unlike a still, non-rotating black hole, a rotating one doesn't simply sit in space. It drags space and time into motion with it, twisting reality into a cosmic whirlpool. The faster it spins, the more violently it tears at the geometry of existence. This isn't poetic exaggeration. It's a precise mathematical truth. The equations describing such an object were discovered in 1963 by New Zealand physicist Roy Kerr, who found the exact solution to Einstein's field equations for a rotating mass. His discovery revealed a new region around the black hole called the ergosphere, a zone just outside the event horizon where space itself is dragged so fiercely that no object can remain still. Even light, the fastest thing in the universe, is forced to orbit in the direction of the spin. Inside the ergosphere, time behaves differently. The closer you drift toward the black hole, the more space-time itself is caught in the whirl. Direction loses meaning, stillness becomes impossible. Here, motion is no longer a choice, it's the shape of reality itself. An observer hovering near a rapidly spinning black hole, if they could somehow survive its crushing tidal forces, would witness time itself begin to fracture. Their clock would tick slower than that of someone far away, not simply because of velocity, but because space-time around them has been twisted by rotation. As the spin nears its theoretical limit, the distortion becomes so profound that the very flow of time near the event horizon slows almost to stillness. From the outside, anything falling towards such a black hole appears frozen in time, suspended at the edge of eternity. But from its own point of view, time continues naturally, unaware of how the universe beyond has left it behind. This paradox is one of the most extraordinary outcomes of Einstein's relativity, and spinning black holes, known as Kerr black holes, reveal just how strange reality can become. Their spin doesn't merely bend space and time, it creates entirely new physics. Because of their rapid rotation, these black holes possess an outer region called the ergosphere, a swirling halo where nothing can remain stationary. Inside it, space-time is dragged around the black hole so forcefully that even light itself is compelled to move. Roger Penrose showed that this drag can be harnessed. A spacecraft entering the ergosphere could, in theory, steal some of the black hole's rotational energy and escape with more energy than it entered with. This Penrose process is not science fiction. It's a mathematically valid possibility predicted by general relativity. Many supermassive black holes, including Sagittarius A, the giant at the center of our Milky Way, are believed to spin at extraordinary speeds. Their rotation powers immense jets of plasma that shoot out for thousands of light years, sculpting the galaxies around them and influencing how stars are born. When you approach such an object, you're not just falling inward, you're falling through time itself, into a cosmic whirlpool where the flow of moments becomes distorted and intertwined with motion. Spin isn't a minor detail here, it's the engine that determines how time moves. In the calm emptiness between stars, space-time behaves like a smooth, steady river. But near a Kerr black hole, that river begins to twist, forming a vortex that drags everything along. This effect, called frame dragging, means that motion itself becomes mandatory. You can't simply hover or stand still, because space-time is moving. Even if you tried to fire your engines against the spin, you'd still be carried forward. Imagine a leaf caught in a whirlpool. No matter how it struggles, the current pulls it along. Replace the water with the fabric of the universe, and that's what a spinning black hole does to everything nearby, including time. Mathematically, this is described by the Kerr metric, which shows that near the event horizon, space and time begin to exchange roles. The direction of time aligns with the direction of rotation. To move forward in time, you must move with the spin. Resist it and your clock slows even more. Align with it, and you can survive closer to the horizon, because you're being carried by time's flow itself. But move against it, and you're effectively traveling backward through time, which would require infinite energy. This strange twisting of reality isn't confined to black holes. Rapidly spinning neutron stars and even some white dwarfs also warp space-time around them, though on smaller scales. Near their surfaces, a second doesn't match a second elsewhere. These subtle differences alter how matter falls, how radiation escapes, and how energy is distributed throughout the cosmos. What makes this all the more astonishing is that spin, something as simple as rotation, can literally reshape the geometry of the universe. Some theoretical models suggest that under certain extreme conditions, a spinning black hole could create pathways through space-time itself, not by tearing a hole through it, but by twisting time so violently that new geometries emerge. In such regions, the familiar sequence of past, present, and future could lose meaning, blending into something altogether different. Spin doesn't merely slow time, it defines what time is. The deeper we explore the universe, the clearer this truth becomes. From the gentle rotation of Earth to the furious spin of black holes, angular momentum is not just motion, it is the sculptor of reality, the cosmic artist carving time and space into their endlessly turning form. When we gaze at the night sky, we're not merely seeing points of light. We're looking into the arms of an immense rotating system, a cosmic pinwheel so vast that even imagination struggles to contain it. Our home, the Milky Way, is not a still place. It spins, turning silently through the dark like a colossal galactic disk 100,000 light-years wide. Billions of stars, clouds of gas, and rivers of dust all orbit around a hidden center, a gravitational heart anchored by the supermassive black hole known as Sagittarius A. Every star, including our Sun, is caught in this majestic rotation. Our solar system races around the galactic core at nearly 800,000 kilometers per hour, completing one revolution roughly every 230 million years. This vast motion is not random. It's one of the great engines of cosmic structure. But where does such spin begin? The story traces back to the universe's first moments. After the Big Bang, matter was not perfectly even. Tiny irregularities grew under gravity, drawing gas together into early clusters. As these immense clouds collapsed, even the faintest hint of motion became amplified, just as a figure skater spins faster by pulling in their arms. What began as the gentlest whisper of movement became the roaring storm of galactic rotation. That spin is not a decorative flourish, it's essential. Without rotation, galaxies like the Milky Way would collapse under their own gravity. The outward push of centrifugal force balances the inward pull, allowing spiral arms to stretch outward and stars to orbit in stable harmony for billions of years. Spin is what gives the galaxy its shape, but it also influences time itself. Every star circling the galactic center experiences time slightly differently. Those near the core move faster, deeper within the galaxy's gravitational well, where space-time is more tightly curved. Their clocks tick just a fraction slower than those of stars drifting along the outer arms. The difference is minuscule compared to what happens near black holes, but across cosmic ages, it matters. Our Sun, living far from the violent core, follows a slightly different rhythm of time than a star near the heart of Sagittarius A, and galaxies themselves interact through their spins. When two collide, as the Milky Way will one day collide with Andromeda, their angular momentum doesn't cancel. It merges, twisting and reshaping both into a new form. The stars, the gas, even the flow of time within them will carry traces of their former rotations. Each galaxy bears its own spin signature, a kind of cosmic fingerprint left by the earliest motions of matter after the birth of the universe. Spin is everywhere. Virtually all galaxies we can observe rotate. Their angular momentum is a record of their origins and an invisible architect that sculpts their form and history. It dictates how stars are born, how galaxies evolve, and how time itself is stretched across vast scales. Every revolution, every orbit, every spiral arm moving through space is part of the universe's great choreography. A slow, deep heartbeat written in the language of rotation. The same principle that keeps a spinning top upright governs the motion of entire galaxies. Gravity pulls inward, while the outward effect of spin creates balance. Together, they sculpt the flat, luminous disks of spiral galaxies. Without this equilibrium, the Milky Way would not exist as a majestic spiral. It would be a chaotic sphere collapsing into dense knots of stars. With spin, it becomes a structured and enduring system, stable enough to foster billions of years of evolution. But spin doesn't only define geometry, it weaves time into that geometry. In regions where rotation is faster, gravity's pull is distributed more widely, softening its strength. Where the spin is slower, gravity deepens its hold. The result is a subtle but real gradient. Clocks near the galactic center tick a little slower than those in the outskirts. The Milky Way itself becomes an enormous, invisible timepiece. Not one that carries you through time, but one that stretches the very flow of time across its structure. Each region lives in its own faintly different timeline, synchronized by the rhythm of the galaxy's rotation. And this cosmic dance extends far beyond the Milky Way. Across the universe, galaxies do not spin in isolation. Their rotations appear to align along the colossal filaments of the cosmic web, as though the entire structure of the universe were choreographed by a hidden hand. Spin is not merely a product of cosmic structure, it's a force that builds it. Over billions of years, it has carved the scaffolding of the universe, giving rise to the order, rhythm, and flow that define everything we see. Spin is the universe remembering its first motion. The eternal echo of the moment creation began to turn. These spinning systems exchange angular momentum like notes in a cosmic symphony. Galaxies merge, clusters form, and every collision passes rotation forward, a baton in an endless relay of motion and gravity. Through all of it, time bends, stretches, and flows according to the rhythm those rotations compose. The universe is not still. It is a dance of spin, a grand choreography where motion defines not just form, but the very timeline of existence. Until now, we've explored spin on vast celestial scales, planets, stars, black holes, galaxies. But spin is not only written in the heavens, it is woven into the smallest threads of reality, alive in the structure of matter itself. In the quantum world, spin is one of the most fundamental properties of all particles, as intrinsic as mass, charge, or energy. Yet the word spin here doesn't mean a literal rotation. An electron isn't spinning like a planet. Its spin is an innate, built-in form of angular momentum, a kind of orientation that defines how it behaves in the strange, probabilistic domain of quantum physics. This quantum spin determines how particles interact with magnetic fields, how they align, and how they obey the deep symmetries that govern nature. It's the invisible architect behind magnetism. The reason a compass needle knows where north is, the reason hard drives store information, and the reason modern electronics exist at all. At the heart of our technological world lies the manipulation of quantum spin, but beneath the practical lies something even more profound. Spin is intimately tied to the structure of time itself at the smallest scales. Every fundamental particle belongs to a category defined by its spin. Fermions, which have half-integer spins like 1, 2, 3, 2, make up matter itself. Electrons, protons, neutrons. Bosons, with whole number spins like 0, 1, or 2, carry the forces. Photons for light, gluons for the strong force, and gravitons, if they exist, for gravity. This simple difference between half and whole decides how the universe builds structure. Fermions obey the Pauli exclusion principle. No two can occupy the same quantum state. That rule gives rise to the architecture of atoms, the periodic table, and the solidity of everything we touch. Spin, in this sense, decides how matter stacks through space and time. Even more mysterious is the fact that spin isn't symmetric. Nature shows a subtle bias, a preference for one orientation over the other. This is called chirality, handedness. In certain interactions, such as the weak nuclear force that governs radioactive decay, only particles of one hand participate. This tiny asymmetry is not trivial. It may be one of the reasons matter survived in the early universe, while antimatter did not. After the Big Bang, matter and antimatter should have annihilated each other perfectly. Yet a small imbalance, possibly linked to the orientation of spin, allowed matter to remain. That imperfection built everything we know. It also may have given time its arrow. If the universe were perfectly symmetric, if every spin had an equal mirror, then perhaps there would be no clear direction from past to future. Time might flow both ways or not at all, but the universe leaned ever so slightly in one direction. Spin's quiet tilt may have been the first choice the cosmos ever made. Spin, at the quantum level, is not a side note of physics. It's the foundation. It shapes how particles interact, how forces act, how matter builds structure, and perhaps even why time itself moves forward. Across every scale, spin tells the same story in different languages, from galaxies to atoms, from gravity to magnetism. It might even be writing the first lines of time. Time, after all, has a direction. We grow older, we watch the world change, and never return to what was. We cannot unburn a candle or unbreak a glass. The universe obeys this one-way current, the arrow of time. Yet most of the physical laws are symmetric, working equally well backward or forward. So why does time prefer one direction? One clue lies again in spin. At the quantum level, spin gives particles their orientation, their handedness. And the universe, in a subtle but unwavering way, favors one hand over the other. In the weak interaction, particles with one-handed spin behave differently from their mirror reflections. Reality itself is not ambidextrous. When particles decay, their spin and the direction of their emission break mirror symmetry. This tiny bias could have tilted the universe just enough to allow entropy, disorder, to grow in one direction only. In a perfectly balanced universe, every spin mirrored perfectly. There might be no forward or backward, no rising entropy, no clear arrow of time. But our universe is slightly off balance, and that imbalance, carried by spin, pushes the cosmos forward, turning microscopic asymmetry into the great flow of time. Even now, that preference is written everywhere. Neutrinos, the most ghostly particles known, only interact with left-handed spin. Their right-handed twins, if they exist, are silent, invisible, and absent from all we can detect. This is not an accident. It is a rule of existence carved into the laws of nature. This is why physicists suspect that the arrow of time is not merely a thermodynamic consequence, but a deeper fingerprint, a trace of spin bias imprinted into reality's foundation. The flow of time is not just a sensation or a story we tell. It may be something particles themselves enforce. Change the spin and you change the day. If Earth rotated faster, the sun would race across the sky in a blur of dawns and dusks. The equator would swell as centrifugal force deepened its bulge, and your weight there would drop ever so slightly. Imperceptible to you, but measurable to the most precise atomic clocks. Time itself would slip by fractions of a second slower at the equator, lagging subtly behind the poles. Air currents would strain to keep up. Jet streams would snap into tighter loops. Cyclones would sharpen, twisting more fiercely under the amplified Coriolis force. The tropics would convulse in shorter, louder breaths of weather, while the mid-latitudes inherited a parade of faster, more volatile storms. Seas would heap higher at the waist of the planet, and tides would retune their ancient rhythms. And beneath that chaos, biology would struggle to adapt. Human bodies are written to a 24-hour rhythm. Hormones rising and falling, body temperature cycling, neurons pulsing in patterns shaped by sunlight. Shorten the day, and you don't just change the clock, you rewrite the rhythm of life itself. Sleep would fracture, hunger would arrive out of step, and consciousness would stutter as if the planet itself were breathing too fast. Slow the earth, and the transformation reverses. Days stretch long and languid. Noon lingers. The sun no longer blazes but loiters, soaking land and sea in heavy, unbroken light. Night becomes an age deep and patient. Winds lose their twist. Hurricanes fade, but deserts spread wider under prolonged suns. Frosts linger longer beneath extended starlight. The engine of weather slows, but the contrast between heat and cold grows immense. The world's circulation reorders. Vast Hadley cells expanding toward the poles. Monsoons becoming epics, climate reshaping itself around the altered rhythm of spin. Even here, on our small blue world, spin is the unseen conductor. It sets the pulse of weather, the length of the day, the cycles of life. From the dance of galaxies to the turning of Earth, from the quantum spin of an electron to the arrow of time itself. All of it, every motion, every heartbeat, every second that passes, flows from the same truth. The universe does not simply exist, it spins. And yet, through all this restless motion, the universe never forgets its rhythm. Every spinning world, every circling moon, every atom humming in the dark is part of a single, unbroken symphony. Galaxies merge and pass their momentum along like dancers in an endless waltz. Stars spin themselves toward collapse and rebirth. Black holes twist the fabric of reality into spirals of time and light. Spin is not decoration. It is the pulse of existence itself, the invisible engine that keeps time moving forward. Faster or slower, every turn writes its own tempo into the world. A quickened rotation shortens the day, draws the equator outward, and makes clocks hesitate by the tiniest fractions. A slower one stretches daylight into long amber hours, pulls nights into deep, frozen silences. The winds change, tides forget their timing, and even the human heartbeat learns a new rhythm. For spin is not just physics, it is physiology, culture, and consciousness. It sets the length of a breath, a story, a lifetime. The faster the world turns, the more fiercely time clings to its edges, dragging at oceans and clouds, bending the flow of air and light. The slower it moves, the more softly time drips, heavy with waiting. Either way, the beat remains. Constant, patient, absolute. Spin does not end with planets or stars. It lives inside the smallest building blocks of matter, encoded in the quantum signature of every particle. Electrons spin, not like miniature globes, but as expressions of something deeper, a property that defines how they exist and how they remember direction. That subtle asymmetry, that tiny tilt in the universe's first decisions, is what gave matter its victory over antimatter, what gave time its forward lean. From the smallest electron to the largest galaxy, every spin is a declaration that time exists, not as a separate thing, but as motion itself made visible. If motion were ever to stop, if every rotation, every oscillation, every cycle fell silent, the universe might still exist, but not in any way we could live within. There would be no dawn or dusk, no heartbeat or orbit, no memory or decay. Without spin, time would lose its pulse. Spin is the hidden clockwork of the cosmos. Every rotation is a second, every orbit a year, every vibration of an atom a heartbeat of reality. Time is not something that flows beside motion. It is motion, measured and remembered. When you stand under a still sky and feel the hush of midnight, remember, the ground beneath you is racing eastward. The stars above are drifting in vast arcs around the galactic core. The atoms in your blood are whirling with quantum certainty. Nothing is still. Not ever. The world turns, and with it so do we. Each revolution writes another chapter in the long story of existence. Spin connects every scale of being, from the shimmer of electrons to the spiral of galaxies, from the ticking of clocks to the unfolding of history. Time is not separate from this turning. It is the turning. It is the endless wheel that keeps the universe alive, unseen yet absolute. The cosmos doesn't tick, it turns, and in every turn, it remembers us.